A very good morning to all participants. Welcome to IChemE Student Chapter Festival Day 2 on PopSig Virtual Site Tour. I am Bashira and I will be your MC for today. I hope everyone is fueled up this morning as we will take you on an adventure through the palm oil processing process, besides diving into the roles of chemical engineers in this industry, which is certainly a treasure to our nation, and some insightful thoughts by the industry players. Feel free to ask questions on menti.com as shared in the chat box. A few reminders before we begin. Kindly ensure that you have a stable internet connection to have the best participation experience. Next, kindly mute your microphone to ensure no disruptions throughout the event. You may type your questions in menti.com using the code in the chat box, and we will direct your questions to the speaker during the Q&A session. Without further ado, please allow me to introduce our first speaker today, Dr. Vignesh Adiapan. Dr. Vignesh is an assistant professor at Heriot Watt University, Malaysia. He now serves as the deputy chair of IChemE PopSig. A brief introduction on our speaker. In 2014, he was the recipient of the Dean PhD Research Scholarship at the University of Nottingham, Malaysia campus. In 2017, he obtained Chartered Engineer qualifications and is currently a chartered member of IChemE. 2 years later, Dr. Vignesh was shortlisted as the finalist for the IChemE Young Researcher Malaysia Awards. Once again, let us welcome our speaker, Dr. Vignesh.
All right, thank you, MC, for the kind introduction. All right, let me just quickly share my screen over here. All right, MC, could you confirm if you can see my screen?
Yes.
All right, thank you. All right, so good morning, everyone. My name is Vignesh. You can call me Vic. I am the deputy chair of IChemE PopSig, and what I'm going to do today is going to give you an introduction on one of the special interest groups in IChemE, or the Institute of Chemical Engineers, which is the Palm Oil Processing Special Interest Group, or in short, PopSig. Okay, so let me run through a few slides with you just to start off the day. So a little bit of about IChemE first. So we know IChemE is about 4,000 members strong. I think this number is probably higher now, and we're based in 100 different countries. All right, we have offices in Australia, New Zealand, Singapore, Malaysia, and the UK as well. All right, and what does IChemE do? One of the few things that IChemE does is, of course, we accreditate university courses and also company training systems and programs as well. So if you're already a student member of IChemE, you would have noticed that you get emails every now and then about the IChemE magazine, which is called The Chemical Engineer, right? Besides that, we also send a lot of emails out on international events and also trainings that are being provided. And apart from that, IChemE also awards the Chartered Chemical Engineer status. A couple of us in the committee right now are already chartered engineers. And of course, we also have a unique qualification, which is a professional safety engineer, process safety engineer status as well. So this is also awarded by IChemE. But before we go any further, maybe I'd like to give some fun facts about IChemE. So the patron of IChemE Malaysia is Her Royal Highness Queen of Perak Darul Rizwan, Tuanku Zara Salim. Her Royal Highness is actually also a chemical engineering graduate. So she did her undergraduate study in chemical engineering as well. All right. And now let's go further into IChemE PopSig, the special interest group. So we are among one of the special interest groups that is affiliated with IChemE. And I'd like to take this opportunity to thank our sponsors. So over the years, we've, as a special interest group, we have done so many activities, and we can't be where we are today without our sponsors. So these are all our sponsors over here. And for students who are actually listening in, okay, this is a good clue for you to find out what are the companies in the palm oil industry and to start figuring out whether they have internship opportunities as well. All right. So please have a look at that. But these are all our sponsors. We'd like to gratefully acknowledge their contributions in our efforts as well. All right. But then again, the question is, who are we? What does PopSig do? Where do we come from? All right. So POPSIC, obviously, it's one of the committees of IChemE members, right? We were formed in 2015, all right, in KL, all right. And what is the purpose of POPSIC? At the end of the day, is to provide a forum for people to come together to exchange ideas, share experiences, particularly in the palm oil industry or for palm oil processing. We have a lot of volunteers who are passionate from the palm oil industry and from process engineering as well. So a lot of chemical engineers who apply their trade in the palm oil industry come together in our committee or in our events and exchange ideas as well. But of course, we're not just limited to chemical engineers, all right? And since we were formed in 2015, just last year, we celebrated our 5th year anniversary, all right? So this will be our 6th year, okay, since it's already 2021. And what are our objectives as a special interest group? Of course, number one is to share and promote best practices, and particularly, of course, in the palm oil industry. And it's also to encourage innovation. So we'll see what are the activities that we normally run and how you guys can get involved in our activities as well. All right. So we encourage innovation in palm oil products. Apart from that, we also promote professional aspects in the industry as well. And we act as a focal point for those who are interested in the process aspect. So, since we are stemming from IChemE, all right, so it's an institute where a lot of chemical engineers come together. So, we look at the process aspect of palm oil processing. All right, so what are the activities that help us achieve our objectives? So we have technical seminars that we've organized, forums as well, workshops, and in fact, our webinars and physical evening talks. Of course, before the pandemic, we used to have physical talks, probably once a month on a Monday evening. But now we, of course, since the pandemic, we have converted that into webinars. So every now and then, if you're a student member, for the students who are listening in, you would get advertisements or emails from IChemE about the webinars that we organize as well. All right, so this is just some of the examples of places of the events that we've organized. Another one is site visits. So this is pre-COVID in that case, all right, before the pandemic. We organize site visits to go and see the palm oil processing plants, or we go to see the refineries, or even the plantations for the matter, any part of the palm oil value chain. So these are just some of the students in the past and universities that have collaborated with us to organize the site visits. And of course, today we are doing a virtual site visit as well, right? So there we are. And apart from that, we also have our very own newsletter. So we have an editorial team in our committee that produces this very interesting newsletter talking about all the various things that are happening in the palm oil industry. And this will be a very useful platform for you to understand more about what's going on in the palm oil industry. And apart from that, we also offered student bursaries. So in fact, the whole point of the student bursary is to provide financial assistance to undergrad and postgraduate students, particularly to encourage them to attend conferences or workshops or forums, but related to the palm oil industry. All right. So the whole point is to build the interest within students. So typically we offer about 1,000 ringgit of bursary. But here's the thing. I'm also going to take this opportunity to promote that opportunity again. So we do have bursaries available. So if you're interested, you'd like to find out more about the student bursaries, if you are interested to go for a conference or an event related to palm oil, do get in touch with us. These are all the social media platforms that we have. And also, this is the general email we have, which is popsicmalaysia@gmail.com. So please, this is a very interesting opportunity. All right. Take advantage of it. Get in touch with us and we'll help you out on how we can go about the process. There's also a QR code over here. You're more than welcome to scan that as well. All right. And as I said earlier, the student bursaries are essentially to promote the interest in palm oil and to assist them if they're already doing any work related to palm oil. So if you're a final year research student and you'd like to go for a conference to present your research on palm oil, all right, just get in touch, all right, and then just find out about the procedures, and then we can work out something from here, all right. And apart from that, this is, since I assume that most of us are chemical engineers here or some variation of that, you have your design projects as well, right? So if you have your design project that is related to palm oil, all right, so this is a good opportunity for you as well. So final year students, typically, all right, so we have some universities that do the design project in other years, but it's a good opportunity for you to apply for this competition, take part in this competition and win a prize as well. So what's the what's the most important condition for this kind of opportunity is that your final year design project has to be related to palm oil. All right. So these are some of the aspects here. So if you're interested to know more about this, you're more than welcome to scan the QR code here as well. Or you can get in touch with us with our centralized email as well, popsicmalaysia@gmail.com. All right. And just to let you know that recently we also had in 2020, we had the winners for the final year design award, which is from Heriot University, Malaysia. All right, this group here that worked on monetization of POME or palm oil mill effluent into renewable energy and green chemicals as well. So, and of course, there's a prize to win as well. So the prize is of course a very lucrative prize as well. So prior to Heriot University, UTM KL team was the one that won the competition as well. All right. So please, if you all have a design project that is related to palm oil, we highly encourage you to apply for this award accordingly. Apart from that, other activities that we do is outreach activities. So of course, at the end of the day, one of the important objectives of POPSIC is to sort of promote the benefits of palm oil and also to promote the industry as well. So we've gone to radio stations, okay? We've gone up to radio segments. We've also met very important stakeholders, okay, like in the ministry and also accreditation bodies and so on. All right, so these are just some of the pictures from our committee members who have done their visits and their outreach activities. Apart from that, also we are heavily involved in IChemE Malaysia's Palm Oil Industry Award as well. All right. So this normally happens every year. So I think for those of you who receive emails from IChemE, you would have seen that there's already an opening for the IChemE Malaysia Awards already, right? So one category you will notice is that the Malaysia Palm Oil Industry Award is also there as well. And apart from that, so this is something I would say closer to where we are right now. Another activity that we have done since 2019 is the university roadshows. So prior to the pandemic, we've been visiting universities, and we've also visited UM sometime in 2019 as well, where we organize events to promote palm oil and to talk about palm oil, and also to see what are the opportunities for chemical engineers in the palm oil industry. So the aim was to stop by 24 universities. So we've gone to quite a number of universities in 2019 and 20 as well. All right. And of course, because of the pandemic, we had to adapt and adjust and be flexible, you know, because of course, engineers, we find a way, right? We find solutions to our problems. So what we did was during the pandemic, we converted our roadshows into virtual roadshows. So this is just some of the clips that of our roadshows. Okay, for the virtual roadshows, these are the universities that we got in touch with and we managed to get participation with. All right, so thank you to those universities for taking part as well. And so what's going to happen in 2021? So what are the events and activities happening in 2021? This is something very important that I would like to highlight to all students who are here. All right, there are opportunities to win prizes. We are offering a lot of competitions as well. All right, so one particular one is after this event, all of you are encouraged to submit a post-event report. All right, so the post-event report is basically talking about what was the event today and come up with a very interesting way of describing this entire event today. All right, so the deadline for this competition will be on the 24th of April. Okay, and there are a lot of prizes here as well to be won as well. Okay, so this is something that I highly encourage all of you to take part in, because this is definitely a very good chance to win a prize as well. All right, and besides that, there are other upcoming events. Let's have a look. So the upcoming events are, we have the oil and fats industry talk as well. So the exhibition, and we have a exhibition where we cover latest available technology in the oils and fats industry, all right, which is a synonymous industry to the palm oil industry, a very interlinking industry in that sense, all right. And POPSIC members, of course, you enjoy a discount. This is also an event which is related to the Oil and Fats International Congress, so it's a conference as well, all right. So if you'd like to know more, the QR code is right here, all right. You're more than welcome to scan that. Besides that, what we have in 2021 is that we are looking at conducting more virtual roadshows, or virtual site tours rather. And these are some of the universities that we've noted down. So this will be announced in the coming weeks or months. All right. So of course, there'll be a lot more universities interested to join in, and we'll be happy to get in touch with them. So there you go. That is for the virtual site tours. and another competition as well. So you can see we are very generous. We are offering a lot of competitions and chances for students to win. So please take this opportunity, okay? So all students are encouraged to participate in a best palm oil theme article. So this is basically the whole objective of this competition is you guys can submit an article basically on the idea of correcting the misconception or misperception on palm oil. All right. And the aim is to disseminate correct information about the palm oil and the palm oil industry. All right. And what is interesting is that the grand prize winner will get a chance to publish the article with our POPSIC newsletter as well. All right. There are also a lot of consolation prizes. So I highly encourage each and every one of you to try this out. All right. So the deadline is over here. It's on the 15th of May. All right. But if you somehow missed out the deadlines, don't worry. You can get in touch with us again. We'll be happy to provide you the information. Okay. And besides that, if you have any feedback over this event today, so today's event is on day 2, right? I believe. So if you have any feedback, please scan this QR code. We'll be happy to hear from you. We are always interested to hear what the students would like to see. Maybe there's something particularly about interesting about the palm oil industry that you'd like us to cover in future events. Do let us know. Do get in touch with us. All right. And let us know what are the things you like as well. So from this event, if you enjoyed something, let us know. Then we'll continue doing that. All right. So, and this is our social media platform. So if you want to find out what are the various methods of getting in touch with us, so these are all our platforms over here. Of course, the traditional one will be the email. All right. But if you prefer going in the other routes like LinkedIn or Instagram, Facebook, all right, Twitter, go ahead. They're all over here. All right. These are all their handles and all their extensions accordingly. So please like and follow us also for IChemE POPSIC as well. All right, so I think that's pretty much it. If you'd like to know further details or if you'd like to get in touch with us, so I've put our secretary's email up front here. So Dr. Hao Bingshen from Swinburne is our secretary. So if you'd like to if you'd like to drop in any queries or you'd like to pitch or propose an opportunity to work together on something, you're more than welcome to do so. We'll be happy to entertain you. All right. Otherwise, you can always get in touch with the centralized email as well at popsicmalaysia@gmail.com. All right. So with that, thank you very much for the opportunity. I'd like to take the opportunity also to thank the student chapter for organizing this event, along with the other student chapters from the other universities as well. So I wish all of you a very amazing second day event. Thank you very much once again.
All right, thank you, Dr. Vignesh, for his informative talk regarding IChemE POPSIC. So guys, do sign up for the report writing competition and win some prizes. Please drop more questions about IChemE POPSIC in menti.com as shared in the chat box. Well, have you guys ever wondered what chemical engineers do in the palm oil industry? The following talk will witness Engineer Hong Wai On from IChemE POPSIC with his sharing session on the roles of chemical engineers in the palm oil industry. For your information, Engineer Hong is the Technical Service Manager of Novozymes, who is responsible for the technical services of vegetable oil processing for Southeast Asia. He is the current Honorary Secretary of the IChemE Malaysia Board and the founder of IChemE POPSIC. Engineer Hong is also a professional engineer, a chartered chemical engineer, and a professional process safety engineer. Once again, let us welcome our respected speaker, Engineer Hong.
Thank you, Chairperson. Let me just share my screen. Yep. Once again, thanks and good morning, everyone. Let's do some light exercise in this early morning. Can you guys please take out your mobile phone, right? Otherwise, you can also open another browser and type in menti.com, right? Menti.com. After that, key in the code as displayed on the screen: 61 17 98 23, and then press word. I believe you should now able to see my slide from your mobile phone, your device, right? And it will allow you to interact with me throughout the session, right? Early morning, already second day. So a lot of people maybe feel a bit occupied and tired, right? Or heavy, right? So let's do some light exercise. So, ladies and gentlemen, this morning, I will actually walk you through the role of chemical engineer in the palm oil processing industry. But before we move on, let's use your device and let us know whether or not you think chemical engineering is relevant in the palm oil processing industry. 0, totally no idea. 100%, very much. Give your feedback, give your reflection. Pause a while, think about that. Whether or not you think chemical engineering is relevant to the palm oil processing industry. Give ourselves some time. The question is indeed interesting because what apparently, I don't say all, but most of the time when we ask students, right? Okay, guys, most of you are chemical engineering, right? After you graduate, which industry that you intend to join or you plan to venture? Most, if not all, right, we choose oil and gas. Fine, I mean, oil and gas, of course, is a good industry, right? Or petrochemical. But very seldom of them actually consider palm oil processing industry. That's why this is the reason why the question asked. How you guys think, right? How relevant of this chemical engineering in palm oil processing industry? Of course, I will not stop here for 1 hour, right? 87%, right? Very good. Out of 52% to respond. Thank you so much. So in the coming 20 to 30 minutes, right, I will introduce the palm oil processing industry. How do we integrate and apply technical knowledge in this industry? That is very important. And at the end, I will share with you the challenges lying ahead. Ladies and gentlemen, or fellow engineer 2P, by 2050, world population will reach 9 billion with significant growth in the developing countries. But arable land per capita is shrinking, with a projected decline from 0.38 hectare per person in 1970 drop to 0.18 hectare by 2050. So the big question mark here is, how can we continue produce sufficient oils and fats to feed the world? Well, palm could be the answer because palm is the most efficient oil crops. You can see from the figure that to produce same quantity of oil, palm requires only 1/10 as much land compared to soy, compared to other oilseed crop. And this figure shows you that the palm oil accounts at least 1/3 of the world vegetable oil production. So, my friends, palm oil could be the vegetable oil of choice in the future. And for your information, oil palm tree grows in the equatorial region, right? As you can see on the diagram there. And those countries are colored in green, as shown. For example, Indonesia and Malaysia are responsible for producing about 85% of the world's palm oil. Meanwhile, India, China, and the EU are the largest importer of palm oil. Those palm oil importing countries are colored in orange or dark orange. For those of you who have not been to the oil palm plantation, here is the picture. Look nice, isn't it? The plantation looks very nice because all the trees are arranged systematically in a neat rows. And you see on the top right is the fruit branches that harvested from the oil palm tree. And when you cut the fruit, you will see the cross section of it as the bottom right. The outer part of it is a mesocarp, which gives us red palm oil, while inside is a kernel, we call it palm kernel, which is used to produce palm kernel oil. And ladies and gentlemen, in some ways, palm oil processing value chain is not much different from oil and gas industry. There is an upstream covering palm oil mill, biogas plant, and kernel crushing plant, followed by midstream processing, i.e. the palm oil refinery. And downstream segment include specialty fats, biodiesel, and oleochemicals producer. So in terms of the usage, about 70% of the palm oil used in food industry, maybe 10% in oleochemicals, and remaining 20% in the energy sector, for example, biodiesel, right? From a helicopter view point of view, right? Palm oil mill produce crude palm oil and palm kernel as primary product. You can see here, there are a lot of the unique operation involved in palm oil milling process. And trust me, many of them are relevant to chemical engineers. Why? Mass transfer, heat transfer, thermodynamic, which I will cover that later. In case you are not aware, guys, this is how the palm oil mill complex look like, right? You have a housing, and then you have the plant sitting next to the housing, and therefore we work, actually we stay in a big community within the plantation. Let's shift the gear a little bit. Oil refinery produce refined oil from the crude palm oil and palm kernel oil, right? And refined oil will go through the fractionation process to separate stearin and olein. Just like palm oil milling process, there are many unit operations involved in refining. Refining can either be done by physical refining or chemical refining. The top route is actually the physical refining, which includes degumming, bleaching, and deodorization, while chemical refining is illustrated as bottom route that includes the alkaline neutralization. Now, come to the fractionation process or the separation process. Stearin and olein will be separated by means of thermomechanical processes, and typically, the final product stearin will be used for the margarine production, or the olein is widely used in the cooking oil and frying oil. And my friends, if you look at the figure on the right, this is not petrochemical plant, you know, but this is oleochemical complex. See? Oleochemical plants produce fatty acid, fatty alcohol, fatty amine, and methyl ester. Of course, I don't want to draw on you, but these materials are widely used for cosmetics, personal care applications, detergents, soap, and cleaners. So these are the raw material for those products. Now, again, next short exercise. Pause for a while, use your device, and tell me what comes to your mind when you think about the product containing palm oil. You should be able to give it a chance to key in three keywords. Type in your answer. What comes to your mind when you think about the products containing the palm oil? Maybe some tips, right? Cooking oil. Yes, come. Hello, engineer 2B. The products, right? The products. Huh? Less cholesterol is not product, yeah, it's a features, yeah. But thank you so much. Yes, I can see that. Soap, biodiesel, cooking oil. Let's come. Any more? The more chosen word, right, will eventually appear the biggest one in the screen here. So I will say that out of 16% here, soap, cooking oil, biodiesel are widely chosen, right, by the fellow student here. Any other thing, any other product that comes to your mind when you think about it contains palm oil? Ice cream, I can see that, yeah. Margarine, yes. Of course, it's Buatan Malaysia, but again, it's a product, yeah. What else? Lipstick. Very sharp, lipstick. Okay, so of course, hey, I can see that shampoo and toothpaste as well. Thank you so much. Generally speaking, biodiesel, soap, and cooking oil. Let's have a look. Time's up, right? There are many products containing palm oil. Cooking oil, body wash, even lubricating oil. Margarine, you mentioned that, right? Soap bar, vitamin E as well. Chocolate, ice cream, and many more. You just name it. So, my friends, it is not unrealistic to claim more than half of the product on sale in supermarket are made with palm oil. This is how versatile palm oil is. Okay, enough for the palm oil processing industry. Now, let's move on to the integration and application of technical knowledge within this industry, right? Our role as chemical engineers is to improve the quality of life. Let me repeat. Our role as chemical engineer is to improve the quality of life. We do this by getting idea and knowledge from people together in the biology, chemical, maths, and physics. Eventually, we put it together and we call it as a chemical engineering science, right? That's the first step. After that, we collaborate and exchange ideas with multidisciplinary teams. This is very important. We as a chemical engineer, we don't work in silo. We actually work across with other people, right? And then when you are properly trained and educated, you can then make the process much more sustainable and safer to ensure the quality of life. So when we go back to the term of quality of life, is basically lying onto two key elements, sustainable and safer. We can apply our technical knowledge in practice, right? These are the subjects that you learn or will learn in your degree. For example, process technologies, right? Safety and loss prevention, thermodynamic, sustainability and environmental. All sound familiar, isn't it? And now you can see the example of this in palm oil processing industry. Earlier I said, chemical engineering are very, very relevant to the palm oil processing industry. Let's have a look. If you learn process technologies, right? And this is relevant to the distillation, the crystallization or filtration, right? Of palm oil. Remember the unit operation in refinery? So this is how we integrate what we learned in the university in the real working life within the palm oil processing industry. And again, if you look at the safety and loss prevention, right? You can apply that in the palm oil processing industry as well. Management of change, hazard, right? You identify the hazard and then you help to improve the safety standard. So if you look at it, you will find that there are a lot of the opportunity for you as a chemical engineer to apply your knowledge in this industry. Of course, I will not go through that, right? Otherwise, you become very, very boring, right? But you can see from yourself. And when we come to the career, it's very interesting to note that, in fact, chemical engineers have a wide range of options within the palm oil processing industry. Is that true? Let's have a look. If you like the plant design, for example, right? Then you could join the front-end engineering and design team, right? Whether it's an engineering company or whether it's a design company, right? You can join them. But when you say, no, you know, Hong, I like process control and I enjoy so much the environment of factory, fine. You could also be a member of the operation team in the palm oil mill, in the refinery, or even in the oleochemical plant, right? There's many, many choices for you. And of course, you could also can become a member of quality and assurance team, just to ensure that the product produced is meeting the specification and requirement. So this is also a key component team within the factory, within the operation team. And some people say, Hong, you know, I like R&D. Well, if you like research and development, you could even continue to do so, right? When you are in the industry setting, many palm oil companies basically set up their own R&D center, right? To develop the new product and to improve the existing one. So this is where that you have a space to play. And some of you like statistical modeling, right? Maybe you could consider become the part of the continuous improvement team, right? A lot of the people within the industry, they pick up the statistical modeling. Eventually, they also go for the Lean Six Sigma, right? And then apply all this knowledge basically to help the industry to perform even much better, right? To uplift the standard bar. And last but not least, being a chemical engineer, you could also take a technical commercial role, isn't it? This is how versatile we are as chemical engineer, right? Across the value chain, there are many, many opportunity perspective for you, for us, chemical engineers. So enough. So what are the challenges right ahead? You know, my friends, always I say, from the self-driving car to the drone deliver online shopping, Industry Revolution 4.0 is changing our life. We cannot run away from that, right? So what does Industry 4.0 mean for students like you? Basically, it is a current trend of automation and data exchange. We can't run away from this trend. And this IR 4.0 basically includes the IoT, right? Internet of Things, cloud computing, cognitive computing, and so on. And it is a digital transformation, right? So new skill will be needed to design, to build, and also to maintain these technologies. And very importantly, we need to think critically and we need to be a data savvy. Let me share with you one report. This is the Future of Job report published by WEF, World Economic Forum, in 3 years back, 2018. Jobs or occupation are arranged into 3 categories, i.e. stable roles in the far left-hand side, new roles in the central one, and the redundant role in the far right-hand side. It is interesting to see the job outlook for chemical engineering related fields are still positive. I highlight it, I circle it with a green color box, right? So my friends, don't worry. You are still relevant in the future, and so much so in the palm oil processing industry. And we see a lot of the palm oil company basically capitalize the industry revolution 4.0 to make their process much more efficient, right? So you have a big role in future. Another question is, what does the palm oil processing industry expect, right, from you, from fresh chemical engineer like you guys? Very important. You must be able to apply your knowledge and understanding to practical solutions. Not just learn, but also you need to apply in the practical solution. And the industry will expect you, right, to manage the relationships. And you have to lead people from different backgrounds, right? And of course, you must also be able to communicate your idea, be it written or verbally. You need to be able to articulate your ideas. And on top of that, I think it's very important that you must commit to high standard of professional and ethical conduct. Last but not least, commit to continuing professional development. To me, this is very important. Your degree transcript is just a key to open a door, isn't it? And you need to continuously pick up the new knowledge throughout your career life. So don't stop, don't complacent, even though you get a good degree in your university, because you need to continue improve your competency throughout your career life. In order to develop and excel, right, in the career, please, to me, is actually connect to create. Connect to new people, unleash energy across your network. Why? Only by connecting to new people, you create new idea, you create new opportunity, right? If you are in doubt, right, let's say after a few years you left the university, if you are in doubt on the fundamental, back to the basics, don't panic, right? We don't expect you to memorize everything that you learn in the university, but back to the basics, right? Ask Mr. Perry, don't ask Hong, yeah? Maybe Hong also forget. Ask Mr. Perry, isn't it? And always, this is far more important. Always uphold professionalism and strive to be trustworthy and ethical. You won't be a successful engineer if you are not trustworthy, if you are not ethical. So this is very important. Uphold the professionalism. Guys, before we end the session, the same question asked, but this is after my sharing section, right? Please let us know whether or not you think chemical engineering is relevant in the palm oil processing industry. I believe earlier we have 87, right? Perfect, 90%. Great to see that, right? At least I do not confuse you guys. At least I impart some insight, some sharing to you guys. So very, very much welcome you guys to join the palm oil processing industry, and let's work together to improve the quality of life. Let's make the palm oil processing industry much more sustainable and much more safer. And thank you so much. And thanks again for the committee inviting me to give a short brief over here. Thanks again. Yeah.
Thank you, Engineer Hong, for the interactive session. I am sure our participants are excited to explore the palm oil industry. Indeed, it is an infamous industry among the chemical engineering students. All right, guys, we will have a short intermission before our next session. Feel free to get your coffee or quick snacks or toilet break, so stay tuned. All right. Hey guys, welcome back. Up next, we have two honorable representatives from KEWPUMP Sdn Berhad for today's virtual laboratory and production tour session with Mr. Cesar Nair and Mr. Chai Jinhan. For your information, Mr. Cesar Nair is the Chief Operating Officer and the Head of Manufacturing and Foundry Operations of KEWPUMP Malaysia Sdn Berhad. He had 15 years of experience in KEWPUMP Group of companies, besides spending 10 years in various multinational companies in Singapore. Meanwhile, Mr. Chai Jinhan is the Chief Technical Officer and the Head of Design, R&D, Engineering, and Quality Operations at KEWPUMP Sdn Berhad. He had 23 years of working experience in KEWPUMP Group of companies. Mr. Caesar will be presenting today, while Mr. Chai will be joining us later during the Q&A session. Please welcome our speaker, Mr. Caesar.
Yeah, hi, good morning. Thanks for the introduction. I'll share the screen now. I'm sharing the screen. One second. Right. Okay, can you all see the presentation? All right. Okay. Yeah, I am Cesar Nair, as introduced. I'm the CEO of KEWPUMP Sdn Berhad. We are a pump manufacturer, and we are one of the few pump manufacturers in Malaysia, actually. So we basically produce industrial pumps, which a lot of you future chemical engineers will be using. And we have our very own factory. It's all made in Ipoh, and we'll just take you on a virtual tour of our plant. So the outline of our talk today is just, we'll talk about our company, introduce our company a little bit. Then we'll just go into the production processes, through which you'll actually be able to hopefully get a feel as if you're actually there at the plant through a combination of photos and videos, right? Just to learn how a pump is made and perhaps get a little insight about maybe what makes up a good pump. And we'll just end this session later on with some information on pump fundamentals that perhaps as future chemical engineers, you'll need to know. All right, so without much further ado, let's go on. Okay, so a little bit about KEWPUMP. So we are a local company, all right, established since 1988, fully locally owned. We actually came about at a time where our founder, back in the 70s and 80s, he was dealing with pumps, actually, other branded pumps, and he actually saw a need because during that time, basically most pumps in the market were imported and being expensive, and he, in the course of selling pumps, he had a trading company, hardware trading company, and he found that there were some perhaps users or the customers that were facing problems with pumps. It's not to say the pumps were not good or having problems in itself, but it just perhaps not suited to the applications required, especially at that time the palm oil market was growing. There was a lot more palm oil mills coming up, so he understood what were the problems. He then looked into what caused the problems, and he just opened up the pumps. Like, he made some changes, he made some design changes, he got people to cast the parts, machine the parts, and after that he let the customers try out the pumps. And yeah, they said, this is great, solve their problems. So that's how we actually got started, and from there we have progressed to actually having a full scope of design, from design, metal casting. We cast our own parts and machining capabilities that we have in our factory. And we have been ISO certified since 2002. Right, so a bit of a background of pumps. Actually, pumps are the second most used machinery in the world after motors. Perhaps not many people know that, but wherever you go in a plant, basically wherever you have liquid that needs to be moved from one process to another, you need pumps. So basically that covers a lot of industries, oil and gas, palm oil, and so on. So it's actually a very vital equipment. It's like a heart. If a heart breaks down, basically the body stops functioning. So therefore, a pump is very critical. Right, so our growth in the industry, of course, started off in the palm oil industry, and it has actually gone on to other industries. And actually, we are quite happy in the sense that we have the trust of many industries, because the criticalness of pumps, being such that our brand, I think, has earned its reputation from being reliable and so on. And we are very happy now to be even not used locally, but we export to over 42 countries around the world. Right, so we have replaced, in fact, many imported pumps in Malaysia, and overseas. Some of our clientele include like Petronas, Kimberly-Clark, which makes paper and pulp, Wilmar, which is a very big pharma group, Simon Darby, and so on. And we're of course very committed to continuously improving our products and innovating and supplying the needs of palm users in Malaysia across all industries, right? So we'll just, sorry, we just go on to a little corporate video for you to see a bit of our company, right? And you can see some of the processes within this video.
At KEWPUMP, our philosophies of keep pumping is to provide our clients a unique experience with our pumps. And to do this, our team anticipates the client's need, understand and solve their operational issues before it even becomes one. We go to the extent of bringing the customer's problem and issues back to our facilities, have a hard look at them, and to determine how best we can solve it. Our pump solutions are a combination of high performance, reliable, and yet cost-effective. And going forward, we aim to bring these unique solutions of ours to more users, both to the new industries and expand our client base around the world.
Since the time we started in the earlier 80s, KEWPUMP Pro have exceeded our expectation. From a 3-man setup in a 300 square feet space to our present 280,000 square feet of integrated facility. We are now serving over 24 countries and enjoy a strong reputation because we introduce new ideas and innovation to our customers and save them a lot of downtime and maintenance costs. Even till today, we are still thinking of new and improved ways of doing things. I do believe there is no such thing good time or bad time, as long as we know the trend and that we always do the right thing.
We are not merely a profit-driven organization. What is more important to us is corporate governance as insisted by the chairman. We want to be fair to our customers, suppliers, and not forgetting our employees too, who we treasure the most because without them, there would be no KEWPUMP today.
We don't see a pump as a pump by itself. We see pumps as a very critical components in our current operating environments. And we want to ensure that our pumps will keep functioning even when other surrounding equipment stop working. So, we design our pumps like the concept of a heart. Heart is a very important organ in our body. While we want it to keep functioning, keep pumping 24/7, and we will have complete peace of mind. And that's why we choose the tagline, keep pumping, to best describe our design philosophy.
To achieve our design concept, where our pumps need to perform reliably and efficiently under the most demanding of working conditions, the main parts of our pumps need to be machined to tolerances that are measured in microns. We also have to ensure that this high level of precision has to be maintained over a high volume of production as well. So to do this, we employ highly advanced production technology and a very stringent quality management system. The main parts of our pumps are all produced in our in-house foundry and subsequently processed in our CNC machining plant center. And some of the machines that we use here are the same used to produce Formula One race car engines.
To sum it up, we have award-winning products and brand name, a loyal and experienced workforce, a strong and dedicated management team, and with our continued commitment to come up with better pump designs and solutions, we aim to give customers a greater level of satisfaction with our products, what we call the KEWPUMP experience.
Right, we hope that gives you a little insight of our plan. So to move on.
At KEWPUMP,
we go to our production processes. Okay, so these are the main processes involved. You all had a little bit of a glimpse from the video this time, I'm sure. You saw some casting processes, right? Where the molten metal was melted and poured. The red hot molten metal, that's where we produce the parts. And then you saw some of the machining going on, the CNC machine. So we'll cover that here. Like first, the process starts with the casting, manufacturing, and then we'll touch a little bit on the R&D. Okay, so in the casting process, basically it starts with the pattern making. Okay, this is where it all starts in terms of, let's say you make a kueh, right? You need the mold to make the kueh, right? Basically, you know, when we make the pump parts, we need the mold where we pour the molten metal into the mold, and then it produces the shape, the pump part itself. Okay, so we have to design the part first, of course, from the engineering department, and then it goes to the casting plant here, and we use a simulation software. The simulation software simulates how the metal will go into the mold, right? And it'll actually kind of like try to help you identify where are the hot spots where the metal, perhaps one section is thicker than the other, so it'll solidify slower, you know, so that's where potentially you have some shrinkage issues, like that could result in holes and so on. So anyway, all this thing, you know, can be worked out with this simulation software, and you know, from there we'll know how we want to do the setup. Okay, so you see here a wooden pattern, right? The pattern is actually used to make the sand mold. Okay, so you can see from the pattern, the shape of it, these are the parts that's going to be produced. Right, we have these two sifus here, you know, combined, they have experience of about 80 over years actually working in this industry. It's not an easy industry to work in, you know, because in this particular function, you need an engineering mind, you need also a craftsman's, you know, creativity with your hands to work the wood and so on. So in anticipation of perhaps not being able to find replacements for them, we have had to turn to technology such as this 8-axis robotic arm called KUKA, right? So this KUKA machine basically, it can handle the part of the wooden working part, right? So you can see it milling the wood over here, right? So this kind of our robotic pattern maker, but you still need someone to design the pattern. So that's where we use engineers, right? So from the pattern, what we will produce is, or what we want to produce is the mold, right? So you can see the different pictures here. These are all sand molds, right? So this is the sand molding line, right? So basically you can see the sand molding line, the pattern, the wooden pattern is there. You can see the sand has been put into the wooden pattern. Basically it's hardened by a binder, right? The sand has a binder included into it. When it's set into the wooden pattern, it will harden by itself after about 15 minutes. And subsequent to that, yeah, you would see this another form of a wooden pattern with the sand mold inside. All right, and okay, so when you knock out the sand mold from the wooden pattern, this is what you'll have. You see the blue areas in the center. Those are actually the area where the molten metal will actually sit, right? So this special coating, this blue coating is put so that the molten metal does not gel with the sand. So here you can see the basically the blue coating. It has a solvent inside which is flammable. So once it's coated, it will be lit up. Then it will dry out whatever moisture from there. And you can see all the different sand molds being in a standing position. And here they have been then taken and put on the trolley. And this is our molding line that basically is like a rail track line. It will then head towards the furnace at the end, right? Of course, the molds will be closed first, right? And then the metal will be poured into the mold. So this is where the casting part comes in. Okay, so casting is basically casting metal into a mold, right? And the metal is first melted in this furnace. This is an electric induction furnace. The furnace melts basically the metal, the whatever raw material that we put in, right? It goes up. It ranges from 800 to 1,000, 6,700 Celsius, 1,000 Celsius, and depending on the type of metal, right? Because aluminium to stainless steel, they have very wide range of melting temperatures. And the raw material that we use, as what you see here, this is an example of it. These are actually very good quality plates that come from other factories. Perhaps they stamp out the parts that they need, like in the automobile industry. Then these plates that are left over is scrapped to them. But of course, it's very good quality raw material, which we use for our melting. And here you can see this is called a ladle. Okay, so the ladle is basically carried by an overhead crane, right? So from the furnace that you saw earlier, it will be transferred into this ladle, and then the ladle will transfer the molten metal into the sand mold. You see the weights on top of the sand mold, it's there to hold down the upper half of the sand mold because the density of the metal is very high. So when you pour the molten metal inside, it could actually lift up the whole upper half of the sand mold, right? So that's why we need to put all these weights in. And yeah, this is a little sample of, if you are standing where I was standing taking the video, you would feel the heat. You know, you feel the heat because this is metal at 1,600 Celsius, for example. And you know, it will be poured into the mold. It has to be poured in a kind of a controlled manner also, right, to avoid turbulence of the molten metal as it goes into the mold. So yeah, we always tell our staff that it's one of the staff benefits is having a free sauna in the casting plant. Right. So after the metal is poured, or before that, rather, we would take a sample. Right. Each melt in the furnace, we will take a sample to test what is the metal composition. Right. So this is a spectrometer, and the spectrometer, the sample will be placed on it, and below it there's actually a point which emits an electric spark that actually burns off the surface of the sample, right, of the metal. And then from the light that reflects from the area that has been burned, the spectrum of lights, that's why this is called a spectrometer. The spectrum of light, each alloy will basically have a different spectrum of light. And this machine is able to read the spectrum, feed it through its processor, and tell what are the components, for example, chromium, molybdenum, nickel, and so on. And it will tell it in what composition in terms of what's the percentage of each of these alloy in the sample, so that we know the molten metal that we poured into the pump actually complies, with what we want and what the international standard should be. For example, like stainless steel 304. Right, it has 18% chromium, 8% nickel, and so on and so forth. And why is this important? Because with the right composition, the metal will form and it will solidify in a certain crystal structure, right? Like austenitic, you see, carbon, silicon, manganese, chromium, nickel, molybdenum. So it tells you all the different composition. Then only when you have the right composition and the metal forms a certain structure, like a diamond, for example, has a certain structure, then you know it can stand abrasion in up to what degree, corrosiveness up to what degree, what type of acid, for example, it can take, and so on. That's why it's very important to nail down the composition. And this is what we invest in this spectrometer equipment like this, to ensure that all the metal composition makes up what is targeted. All right. Okay, so you all might be familiar with this chemical periodic table. On the right is just a sample. These are ASTM standards. Okay, so for, let's say, 304, stainless steel 316, these are the kind of composition of the alloys that you must have to qualify to call it stainless steel 304 and 316. And we can issue what you call mill certs to clients if it's necessary, if they require. Okay, so that's the casting process in a nutshell. Then after casting, all right, the parts, will be cooled down, takes about 24 hours. The next day, it will be knocked out from the sand molds. It's only a one-time use, the sand molds, and the parts will then be cleaned. Will be put through this heat treatment, which is very important also, because the heat treatment just tempers the metal, normalizes it, or you can even harden it and so on. And then it will be put through this is the empty furnace, and this is, you can see the parts are heated up red hot, so to produce different kind of effects, the finishing effects of the material for performance purpose. And this is just a sandblasting machine. Right, so from the casting process that's done, we have the parts now, the raw parts. So it goes to the manufacturing process. Okay, the manufacturing process covers all this: machining, pressure testing, impeller balancing, QC, and assembly. So for the machining, basically, we have these metal parts now, right? The metal parts are raw, right? So it needs to be machined. Purpose, the different parts of the machine areas need to be mated or joined to another part, right? So where those two parts need to be joined, it needs to be machined, and to have the mating surface, right? Just very, how you say, fitting, right? Fitting, so that there's no leakages, there's no gaps in between for the parts to vibrate, right? So this is just one of the CNC machines. Okay, so the CNC machines are basically computer control. It's programmed. So the operator here, the person is programming the machine to run a certain program, basically what to cut, where to cut, how much to cut, to what depth, and so on. And this is a little video. Okay, here the part is turning. This is called a lathe or a turning machine, where the part turns and the tool is stationary. A milling machine is the other way around. The tool turns and the part stays stationary. Okay, so these are some further example. This we want to highlight this machine also because this is the shaft machine, the machine that machines the shafts. So this is a very critical part, of course, the shaft, because the shaft rotates at few thousand RPM. It has to be machined very linearly. You know, that what makes a good pump also, because if the shaft, of course, does not get machined properly, there will be some extent of vibration, maybe not felt physically, but it will be there. That's what deteriorates the seal, causes the pump to vibrate, you know, and then have high wear and tear. You can imagine if your car engine has a lot of vibration, you know, it won't last very long. Right. So this is the machine that machines the shaft. Okay, so you can see as the machining process is going on, the tool is cutting it, right, following the program set, and you can see the chip that's produced, and then you can see the coolant, right? All those liquid is basically the coolant or the lubricant that helps the tool to machine and cools the part down so there's no expansion. These machines are very precise. These are Okuma machines from Japan. They can go up to tolerances of like 5 to 15 micron or 10 micron. The human hair is 100 micron, right? So you can imagine 10 micron. It's a very small figure, right? This is another machine. Okay, this is a pump casing, for example. This is a vertical lathe machine, right? These are for bigger parts. The tool is from the top, that's why vertical, and then the part is at the bottom, right? So it's machining the flange or the suction part of the pump. Okay, we will just go into that a bit later on. Right, this is the control panel. All right, so that's the machining process. So after that, we have this process called the water pressure test. These are for all the parts of the pump that basically hold pressure, right? Because pump basically is a pressured vessel, right? It has to have pressure inside, and through that, the liquid can be forced out into the next process. So this is just a water pressure, basically tool, right? That we will set. Let's say this pump is supposed to perform at 6 bar, for example, of pressure, right? So we will test it to, let's say, 12 bar. Maybe we will ramp it up, and then we'll seal all the openings in the pump casing, for example, and then we'll put it up to 12 bar, and then we'll see if there's any leaks, or this is just a QC step. And then for the impeller, very critical also. These are the critical steps actually we do. This is the impeller balancing. So the impeller is one of the rotating parts, right, together with the shaft of the pump. So kind of like your car tire, you know, when you fit a new tire, you have to balance the tire, because if you don't balance the tire, when it's manufactured, nothing can, you know, be manufactured perfectly, right? So like impeller here, it's casted, as you can imagine. Perhaps some parts of the impeller might be a bit heavier than the others. So what this machine does is it will compute using its sensors and a computer. Basically, it will tell you where's the coordinate 0 to 360. So this impeller has a bit of extra weight imbalance at degrees of 306, right? A certain area. So it will be marked that area, and machine will tell you how many grams it is out of balance by. So we will, by experience, you know, remove that excess metal in that area, and then we will run it through, and this will be done continuously until we get a reading that the impeller is balanced, right? So when it runs in your pump, you won't have vibration problems, you will have lesser maintenance issues, and so on. Right, so that's the impeller balancing, and all right, then we have some QC procedures here, right? Usually it involves dimensional non-destructive testing, NDTs, and here, you know, we're using calipers to measure the diameters, and this one, for example, we are using a 3-point caliper to measure the inner diameter of the bearing stuffing box cover, where the bearing sits, right? Very important, because when the bearing runs, you know, with the shaft in it, in vibrate, it will heat up, right? And when it heats up, it expands. But then the area that it sits has to hold it firmly, right? So it has to be a very precise dimension that is able to hold the bearing, right? But also not get it too tight when the bearing expands. So that's why we have to use equipment like this. it can give you up to micron level. So this equipment, right? And this is another equipment we use for QC and dimensional. This is called a CMM machine, right? So basically, it works on the basis of the machine has a very flat table, usually made of marble. It works on a fixed axis, right? So here we are doing a part for the first time, so we are programming it. So this probe, you can see at the end of the probe, in the part there, there's like a needle-like probe. That probe, this CMM machine will move it, right? And then it will touch the different parts of the part, right? So it can tell the coordinate of that part, let's say at the bottom part. Then after that, as it moves up to another point, it will touch. So it can tell the difference between the first point and the second point in a very precise manner. Again, we are talking like 5 micron, 3 micron kind of level of precision, right? So that way we will know that these parts are precisely machined so that it fits well. That's the most important thing. It fits well together so that you won't have areas for vibration and your pump can last long time, you know. If the car, for example, you know, if you have a car that vibrates wrong, you know very fast the car will start to give problem. All right, so similarly, for a pump that works with the same principle. So after all the parts have been checked, right, for its dimensional accuracy, so we can start to assemble the pump. Okay, so here you can see the pumps are assembled not in like a car production line, right? Because all these pumps basically are made to order, right? It's basically each pump is handmade, basically, you can say that, you know, hand assembled one by one, because one customer may need even a number of pumps which have different configuration of impellers, materials, sealing systems, and so on, you know. So that's why each pump has to be this made to order, specifically custom built, basically, you know. So I like to term it like how a Swiss watch is made, hand built, handmade. But of course, our pumps are much cheaper than Swiss watches, right? Okay, so after we assemble the pumps, if the customer requires us, we would then have to couple the pump to a motor, right? If the customer just needs a bare pump, he just takes a bare pump because perhaps it's a replacement pump, they already have the motor in place. But if they need a motor like this, right? So basically, the pump will be placed on a base plate. You can see the base at the bottom, coupled meaning joined to the motor. And basically, the shaft of the motor and the shaft of the pump have to be perfectly aligned, right? There are other ways of doing this traditional ways where they use ruler and so on. But we use one of the most precise ways. This is a laser alignment machine. Basically, you see the red cap there. It's like a lens cap. Later, the operator will take that out. Technician will take that out, and there'll be a laser that is able to align from the pump shaft to the motor shaft, and it'll tell you exactly by what measure it's not aligned with, and which area it's not aligned. You know, whether it's left, right, top, bottom, and so on. So then the technician will know what he needs to do. Basically, you need to adjust either the level of the motor or the level of the pump. So this is a German piece of equipment, this alignment equipment here. Right, so you can see now he's loosening the motor. Right, then you put a shim, right? So this is very important for you guys also, because in future, you know, when the pump is installed, you see it's aligned at our factory, but when it's shipped to your place, perhaps handled by a forklift, a truck, it goes on the ship perhaps, and so on, you know, all the handling, it might just cause the pump alignment to run out a bit when there's movement, right? So it needs to be aligned again at the site, right? At site itself. So either if you guys have the knowledge equipment, you can do it, which, you know, a lot of companies, they have this, or you can call people like us to, you know, come and do the alignment. Right, so that's final product basically. Pumps, the one in the yellow, and you see the motors on top. This is a different configuration. This is a vertical configuration. Right, so that covers the manufacturing process, right? So so now we have our pumps, and like within KEWPUMP itself, we have a lot of R&D, and this is some of the things that we use, like this AutoCAD software. You know, we have 3D modeling.
You're out.
How come? Yeah, sorry. We seem to be kicked out from here. Must be some software thing. Yeah, could be the line. Straight to the- Bear with us a minute. This is actually our first virtual tour of a factory in our history of KEWPUMP. So must congratulate you guys. You guys are the very first people who actually have come to our plant in a virtual way. Yeah. Okay. So you can see the AutoCAD software we use. This is a 3D scanner. We use it to scan our pattern molds and certain parts, to keep it in electronic form. And we can do further R&D by scanning it. And this is a 3D printer, right? 3D printer, we use it to make prototypes. We also use it to perhaps, earlier you saw our wooden patterns, because we need to, prepare for, when perhaps we won't have the skilled craftsmen to make the wooden pattern, so we will print out in ABS. This 3D printer basically prints out. You have a 3D drawing and you put it into the 3D printer. So what the machine is doing is it has the 3D drawing, right? So it will level. This is liquid ABS, so it will level the top. The laser will actually shoot. You can't really see it. The laser will shoot layer by layer, right? We're talking about maybe 0.3 mm at a time, right? And then after it burns and solidifies the top layer, then the table will go down, right? And this bar will go across it again, level it again, and then the laser will again print on it, right? And then after that, it will go down, and so on and so forth, right? So that way, then you can see the laser moving there, right? The bright light, that's the laser burning the part, right? Okay, so after that, the table will go down, and yeah, so this is then done, and it takes hours. Depending on the size, it could take 24 hours, for example, to do this, right? So these are the parts produced. Okay, you can see these are still joined. They have this support, so you have to have a support of the part to the table, and you can see it will layer by layer, so you can measure the time taken, 0.3 mm at a time to produce parts like this, right? And this is our pump test bed. This is where we test the pumps. When we make a new pump, or when a customer buys a pump, like Petronas, for example, they need to test every pump that we make, because these are very high-end kind of usage. For example, India, in India as a context. So the pumps will have to be tested. So like, for example, we make a new pump, we will need to know the performance of the pump, right? How the flow of the pump, the pressure, the head and everything. So like we have the software here. This was developed with a university. So we, UTM actually, we actually have all the sensors in the pump test bed. It will feed back to the software, and then it will actually tell the reading of the pump performance, so that we can form the pump curve, right? The pump curve is basically, we'll go into that a bit later. So that will tell you what is the performance of that particular pump model, right? So that's our production process in a nutshell. So we just go a little bit into the pump fundamentals, right? For you guys as future chemical engineers, we can't really go into it in depth because there's a lot of technicalities, involved in pumps, and we'll just give you roughly a rough outline what to expect. So what are pumps? Basically, pumps are machines to transfer liquid, right? And it transfers it to different principles. Basically, it's to increase the pressure of a fluid, create a vacuum. Basically, by doing that, it's able to move the liquid into another process and so on. All right. So it's the second most used machinery, as I mentioned. So generally, there's two classes of pump, right? One is dynamic, and another works on the principle of displacement. The types that we make, the type of pump that we make, are mostly centrifugal pumps, right? So centrifugal pumps work on the basis of energy is continuously fed, right? And it turns, for example, the impeller in the pump, right? And this velocity is continuously increased, right? And what it creates is a pressure within the pump that then can expel the liquid out, right? From the inlet to the outlet, right? And displacement pumps work in a different principle. It's kind of like you can imagine, like, for example, a piston, right? A car engine, a piston, you know, as the piston moves up and down, that way it creates a certain pressure also, right? So it moves the pumps in that way. It is not a very high flow kind of method. You can see the chart here, right? Roughly showing pumps dynamic displacement on the left, shows you centrifugal pumps, what are the different types of centrifugal pumps, mixed flow, single suction, double suction, and so on. And yeah, and peripheral and so on. And then on the right, you can see displacement pumps, right? You got your piston pump, you got your diaphragm pump. Diaphragm pumps like a rubber, like a heart, you know, your heart pumps, but instead this one uses like a rubber diaphragm to move it, right? So the most used pumps in the world are actually centrifugal pumps because they are the most versatile. Okay, so within the pump casing, there's this impeller, right? So the impeller rotates, as you can see from the picture there. The liquid goes into the eye of the impeller, the middle of the impeller. And as the impeller rotates, the vanes push the liquid to the sides around the inner periphery of the pump casing. And that basically converts it to pressure and then forces the liquid to be discharged from the pump, all right? And these are the major components of a pump. If in future you open up a pump, this is what you'll see. All right, you'll see the pump on the right first, the pump casing. You can see the pump casing, the front of it, right, is the inlet and the top of it is the outlet. So the liquid comes in through the inlet, goes through the impeller and is pushed out. And you can see the inlet is bigger than the outlet. So there's another thing that contributes to pressure. More coming in, lesser coming out. So it's spurted out and together with the help of the impeller rotating within, right? So then it goes up the pipe, right, and goes to your next process. Then you've got the bearings, you've got your shaft. And another important thing is the seal, because the shaft comes out from the casing, which is a pressured area of the pump. So it has to have a seal that holds the liquid from coming out. All right. So different impeller types. There's this closed impeller. This is a higher efficiency one, but it cannot handle a lot of solids because you can see the two plates there. There's a narrow gap in between. So it cannot handle a lot of solids. Right? Solids like semi-open impeller, solids like what you have in a palm oil mill, for example. You've got sand, sediments, maybe some parts of the palm husk, nut, and so on. Right? So a semi-open impeller would be probably a good balance because it can handle a certain amount of solids, but at the same time, it has a certain amount of capacity. Right? So kind of impellers that we have like a closed, semi-open, and this is a fully open. It's like a propeller, right? These are where the solids are very big, but of course, these are not the most efficient impellers, right? Because there's no plates to hold the pressure, the liquid in, right? So the pressure, of course, will be a bit reduced, right? But of course, it has to be used in its own required applications where the solids are big. Right, so we come to the pump curve. This time you saw the pump test bed. The pump test bed basically helps us to arrive at the pump curve. The pump curve basically just tells us what are the pump performance at what kind of power that we put into the motor, what kind of flow can we get. So as chemical engineers, you will need to know, like, based on how far you need to pump the liquid to your next process, the piping length, how many elbows, the viscosity of the fluid, the diameter of the pipes, and so on. So then you can match it to the correct pump, right? Because each pump curve will show you what it can do, and then what is your system requirement. Then you match it to the correct pump with this pump curve. Right, so these are the different things that you will come across, right, when you deal with pumps: pressure, head, flow rate, specific gravity, viscosity, cavitation, and net positive suction head, NPSH, power and efficiency. These are terms which in itself is, is a lot of detail, but just to expose you a little bit to these different terms, right? Okay, so that in a nutshell is what you'll need to know fundamentally as chemical engineers if you deal with pumps. And yeah, for our contact information, perhaps like internship and all, you can shoot an email to our email here, inquiry@kewpump.com.my, and that's our website. You can go there for further information about the company, and you can learn more about pumps there. There's even calculators for you to calculate certain aspects, engineering aspects of a pump and liquid and so on. And basically, we've come to the end of our presentation. This is our office building. That's some of our staff. And on behalf of KEWPUMP, thank you for having us. And we hope you learn a little bit more about pumps and hope to, meet you somewhere down the line and have a good career to all of you all. Right. Thank you.
All right, thank you so much, Mr. Cesar Nair, for the insightful session just now. For your information, KEWPUMP today is an award-winning and one of the leading pump manufacturers in Southeast Asia, exporting stainless steel and suction centrifugal pumps to over 40 countries around the world. Again, do spam your questions in menti.com as shared in the chat box. Therefore, it is time for our first Q&A session with IChemE PopSec and KEWPUMP Sdn Berhad. I will be reading out questions from the menti.com website, and if you have any other questions throughout the 3 sessions we had previously, feel free to type your questions in the link provided in the chat box. We will direct your questions to our speakers later. Well, our first question is directed to IChemE PopSec. We know that non-renewable energy sources are depleting year by year, and many are shifting to renewable sources like biofuel. As of now, how advanced is the plan of turning palm oil into biofuel to replace diesel?
I think we can invite all the speakers to open up their video feeds. I think this is already a discussion session. I think we can go ahead. So probably myself and Hong can address this question. But Bashira, if you don't mind, could you repeat the question again?
We know that non-renewable energy sources are depleting year by year, and many are shifting to renewable sources like biofuel. As of now, how advanced is the plan of turning palm oil into biofuel to replace diesel?
Okay, so I can chip in first, then probably I'll invite Hong to add on as well. So I think in terms of advancement, I think we are already at a stage where it can be commercialized. It's just a matter of implementation and policy related to it as well. So I think in that sense, because Malaysia is leading on this front in terms of biofuel, and in fact, palm oil, when we export biofuel to other countries, one of the primary uses is actually to produce biofuel. All right, but for us here, the major demand is like cooking oil and so on. Yeah, but when we export it, it's definitely already used. So in terms of establishment and advancement, it's already available. Yeah, but Hong, over to you as well.
Hey, thanks, Dr. Vic, and thanks for the question. I think this is very sharp. Just to add on a few reflections. One, maybe I need to reiterate, not say reiterate, but I need to emphasize or remind that, a fellow engineers, right? I call you engineer. Palm oil mill, especially palm oil mill, is self-sufficient in terms of the energy. In case you are not aware, palm oil mill, they do not rely heavily on the fossil fuel, right? Because they generate their own biomass, and then that biomass basically feed back to their steam boiler, right, to generate electricity. So that is one part. The industry is doing very well in terms of the renewable energy. Second part also, the industry, like what Dr. Vic mentioning, a lot of people right now actually converting the palm waste, right, palm waste to become the biodiesel, right. This is also speak in terms of the progress. In fact, a lot of the plants already commercialized, not in R&D stage, already commercialized, converting the palm waste to become the biodiesel. And not to forget also, because of palm oil industry, right? So our country basically generate a million tons of the biomass annually, right? For example, the fiber or palm kernel shell. And do you know that all this biomass basically we ship out, export to the other country, for example, Japan, Korea, because these countries are actually promoting the renewable energy source, right? So this biomass eventually will feed to their biomass boiler for electricity generation. So long story short, in terms of the renewable energy sector within the palm oil processing value chain, I believe the industry is doing very, very well. Of course, room for improvement, waiting for you guys, right? How to actually make the process much more efficient. But in a nutshell, the industry already embarked on this renewable energy. Thank you.
All right, so we'll move on to the next question, also directed to IChemE PopSec. Do you have any info on the article competition where the deadline is on 15th of May?
Okay, so the competition details are available on the PopSec website. All right. And if you want to know more details, you just drop us an email and we'll clarify any further doubts that you have. Yeah. So the email I think I put in the chat, but our website, you can just go on to Google, type POPSIC, IChemE POPSIC, definitely the first result that you see. All right. Then go over there. We already have all the details available there. Just explore our page over there and you can see the information is available there. Yeah.
All right, thank you. So the next question is directed to KEWPUMP. What is the function of KUKA robot in the industry?
Hi, Caesar.
Yeah,
Hi, everyone. I'm
yeah.
Jinan here. Caesar, you want to answer this question?
Yeah, okay. The KUKA robot, basically it's a multifunctional, right? So if you're talking in the context of general industry, you will see KUKA robots in car production plants, where it's lifting things or it's doing welding and so on. But for us in our context, we actually bought a specific module, where the machine has a head that can do actually milling, wood milling, right? So it's kind of like an arm and then whatever you want to attach to the end of it to suit your purpose. And it can be programmed to do multiple things. So I think it's something that going forward, Industry 4.0, we'll start to see more of in use in industry. Yeah. Hopefully it doesn't replace too many people's job.
So another technical question to KEWPUMP. May I know, since the pumps are manufactured customly, how long does it take for a pump to complete the design to assembly process?
Okay, if it's custom make something that's close to existingly what we have, it will take shorter time. But if something that, for example, like we had an inquiry, like one customer wanted, in oil installation, we have a silo tank, and on top of the tank, there's a small hole, right? And then he wants the oil that floats on the top of the tank. He wants to recover it because he doesn't want to just waste it, So he needed a pump that could go in the top, float on the top, and then after that skim the oil on the top, so we had to design something that had like a tripod leg, but the tripod leg will be basically like ballast, it could float, so it was collapsible, right? So when it goes in, it could open out like that, sit on the top, and then suck, so yeah, that kind of thing would probably take a little bit more time, but we are looking from anywhere from maybe a month, let's say, to 4 months or so on. Yeah, it really depends on the design of the pump and what's involved. Yeah.
Sorry, can I add on this question?
Yeah.
Just to clarify, actually, not all our pump is custom made. Actually, we have a range of the pumps, and I believe that what Caesar means of custom made means that we have to like customize a different pumps to a different applications. Then most of our pump actually is already not say ready made, but we made by product by orders. So basically, we have to understand and know what you need, what kind of pump, what sizes, what the pressure and capacities. Then we size our pump, then we produce the pump accordingly. This is so-called a customization, not really customize a pump from scratch.
All right. So thank you so much. So we have another question for KEWPUMP. How is the pump competition in the market now?
It's of course pretty intense. Pumps have been around for a long time, right? So you have different manufacturers, but it's at the same time it's quite a difficult market to go in, right? Because there's a lot of how you say industry or technical knowledge involved. But in terms of in Malaysia, we have mostly a lot of imported pumps. And actually, like in the palm oil industry specifically, like previously it's all imported pumps. So when we came in, we were able to perhaps produce the pumps that met the needs, perhaps specifically being manufactured in Malaysia. Of course, we have a cost advantage, So eventually, we did replace, I think, all the imported pumps in the palm oil mill, and I think it's a model perhaps that we also have this kind of perhaps capability in other industries. So yeah, it's fairly competitive. Definitely, it's fairly competitive. Yeah, but I think in the context of KEWPUMP, because we are made here, we have certain advantages perhaps, right? And we are especially importantly to users is a support, because we are here. If there's anything that needs our support, we can attend to it, because we are nearby. Yeah.
Right. All right. In regards to internship opportunities in KEWPUMP, When is the usual recruitment of interns and new graduates?
We leave it to the universities, basically. Different universities we find have different intern periods, right? Some at different times of the year in general. So we are open as long as there's vacancies for interns, in our company. So as and when we receive the applications, we will then, based on vacancies, then we will just take any student in, not at a specific time of the year. Yeah.
All right. So another question is quite open-ended. Palm plantation is seen as a cause for deforestation, which leads to other environmental issues. What are your views on this?
So probably Hong and I can lead on this lah. All right. So it's more of a question on where these are occurring, and who is managing this. All right. In general, deforestation in policy wise, we have banned deforestation. There's no, it's not an acceptable practice. And in fact, in terms of land cover for forests, right, the forest cover, we have not decreased in a very, very long time. So if at all we notice that deforestation has been occurring, this could be, so maybe malpractices happening by individual companies which need to be investigated, So this is not a practice or a common thing in the palm oil industry. So every now and then we see reports that, oh, it's the palm oil industry, it's the palm oil industry. One thing I would like to let everybody know that this is actually a very misleading point. It's not the whole entire palm oil industry doing this. The palm oil industry understands that they should not be doing this. It's just that you have, like, in every sector or in every industry or in every workplace, you have a majority of them complying, but you always have that one or two that, stray off, and you need to regulate them a little bit. And that happens. But in terms of deforestation, I think in terms of policies put in place and the practices in palm plantations by big corporations and all that, they're fully aligned with the sustainability aspects required from that point of view. Yeah.
All right, there's a follow-up question for the internship at KEWPUMP. As an intern at KEWPUMP, what is the expectation of an intern?
Basically, to be frank, we don't have high expectations of interns. Not to say because they're not capable, but basically because of the level of experience, as you come in as a fresh grad. So we try, in fact, to produce maybe an environment that the intern can learn as much as possible, because it's in a very short time, 3 months. How much can a person learn in 3 months, to be frank, but we would expect them, of course, to come with an appetite to learn, a willingness to do as much as they can, and then basically just to also, at least get a feel of the working environment, because it's very different from an academic environment, so the expectations are different, and maybe they can go away from that. Then perhaps when they start work, at least they'll be better equipped to start work. But pumps basically quite specific. So to learn something in depth about pumps in 3 months it's a bit short of a time. Yeah.
Another follow-up for that question. What are the job scope for chemical engineers, since most of the pump production involves mechanical engineering knowledge?
Yeah, for like manufacturing, yes, probably mechanical engineering students would probably be more, not say suited, but I think also, in the same breath, if let's say the chemical engineering engineer has, or the potential chemical engineer has an interest more in manufacturing, right? Then I think engineers in general are equipped with an analytical approach towards things. So, if they have, it depends on what their interest, because basically you have to also see what's your passion, right? If you're a chemical engineer, but maybe you're not passionate about the palm oil industry or oil and gas and so on, maybe you want to do R&D in terms of making things like, manufacturing things. So then if you go to let's say a company like ours, with your analytical kind of approach towards things, that how you have been conditioned and trained for, you can easily adapt. Yeah, because a lot of the things are based on the job kind of training. Yeah, because palm manufacturing basically it's like I said, quite a niche industry. Yeah, so yeah, as long as you got the right software, you know, the database can be filled lah. Yeah, you know, so yeah, so should no issue. This depends on the interest of the particular individual.
Yeah, I would give an alternative to that as well. In fact, at the end of the day, it's pumps, you know, and chemical engineers do design, they do their design projects, they have to select pumps, you know, so having that fundamental knowledge, and in fact, from Caesar's presentation today, by right, none of this should be foreign to chemical engineers, especially the selection of pump, the NPSH, the efficiencies of the pumps, all these sorts of things. So having a firm understanding in this area, I think when you meet clients and all that, you kind of know what they're asking for, you know, and you have that idea. So I think this kind of fundamentals are very crucial, particularly for chemical engineers to join companies like this in that sense. So it's good to understand what people are looking for. Yeah.
All right. So our next question is directed to Popsik. What kind of waste are generated in the palm oil industry? What measures and challenges are faced to manage this waste?
Right. So I'll add on what I can. Hong, you know, you can compliment me as well. So there are many kinds of waste which provide us an opportunity in the palm oil industry to utilize. All right. So of course, the main product in the palm oil mill is crude palm oil. But as you're producing crude palm oil, you have different kinds of waste, such as you have the palm kernel shells. Okay, you have mesocarp fibers. You have empty fruit bunches. You also have the wastewater called pommes, which I may have mentioned that word earlier. So palm oil mill effluent, yeah. And you also have like decanter cake and various others. So there's a lot of research and being done on the potential of using all this biomass. And in fact, as what Hong mentioned earlier, a lot of this are actually being utilized already, all right, in the industry. They're actually being used for generating heat and of course, eventually power. So some of you may know the technology called combined heat and power or cogeneration. So a lot of mills are actually generating their own power, as what Hong mentioned earlier. So this is what we mean by self-sustain. Imagine you produce the waste, your waste becomes a fuel already, you know? So a lot of companies are doing that. And what happens here is that the efficiency of those mills become higher because now your waste is coming out, but you're still utilizing that waste to supplement your process entirely. So in that sense, number one, self-sustain. You reduce your operating costs because you don't have to buy electricity directly from the grid. You don't have to look for connections in that sense. So in that sense, there's a lot of opportunities there. In fact, some mills tend to sell their higher value products by doing briquetting and start pelletizing while they use their lower value products for energy generation as well. So there are a lot of opportunities there in that sense. Challenges are, of course, like in any process, there are challenges as well. So efficiency is, you know, we try our level best to reach 100%. You know, we try our level best. Of course, we are not at 100% because we know mechanical engineering and chemical engineering states that, you know, due to certain reasons, you know, it's thermodynamically difficult, limiting to reach, you know, that high level of efficiency. But what engineers do, or what process engineers do in this context is, we're trying to improve the efficiency further. What is the most economic way or strategy to utilize all this waste? That's number one, right? So there are other aspects such as considering further expansion. So this is also another challenge as well. If you want to expand your operations as well, or is there a potential to extend the energy that you generate from the mills to supply to the grid? So this is a question of feed-in tariffs as well. So there are interesting challenges here, which you know, a lot of people in the industry are working very closely. And the pommes thing I mentioned earlier, a lot of people in the industry are producing biogas using pommes. So that is also an interesting area as well. And a lot of mills have also implemented that as well. Yeah. So Hong, over to you. Go ahead.
Thanks a lot, Dr. Wei. I think you cover very well. Perhaps I just want to add on beside the palm oil mill, right? The palm oil refinery also produce some waste, right? Because they do the fractionation distillation. So that waste basically is actually being capitalized as a feedstock for the biodiesel as well. Just now a question asked, right? How are we, or where are we in terms of the renewable energy sector within the palm oil value chain? So true enough, in not only palm oil mill, but in fact, some of the waste generated at the downstream sector, right? already been used as a feedstock for biodiesel. What does it mean? That means when we say about biodiesel, the feedstock might not necessarily come from the crude palm oil itself, right? It can also come from the waste product that generated across entire value chain. Again, long story short, it's actually, the industry seems to be embarking on this journey already, but always there's no 100% efficiency, right? So again, welcome everyone here to help us to improve the efficiency. And again, very important, how to make the process much more sustainable and safer. This is a job of an engineer, especially chemical engineer. It's a challenge to you guys. Help us.
Yeah, and very interesting point that Hong brought up. In the refineries as well, some of the processes can have high energy requirements. So what industry people have seen and also researchers have seen is that there's opportunity to do heat integration or do heat recovery. So there's also opportunities there as well. So we don't call it as a challenge, it's more of an opportunity to optimize it even further. So a process optimization is definitely always an option to consider for further improvement in that sense. Yeah.
All right, thank you so much. For the next question, I believe that it is directed to KEWPUMP, but feel free for other speakers to give your opinions. Is there any plans to implement AI or CI into the process, like for asset maintenance or other parts of the process?
Yeah, for our plant, we do have plans to do that. In fact, we're trying as much as possible to move towards like Industry 4.0. We actually have quite a few automation kind of equipment already installed. Like for example, the KUKA. Not everything can be actually converted to like IoT. Integrated together and all that. Some things are still very manual, but we also have software. For example, we got a grant from the government basically where we can measure our OEE, our operational efficiency. So the machine actually records the productivity of each machine, and from there we can have a view of the shop floor from the screen. So we also are moving towards like simulation software, things like that lah, as far as possible. I would say that it's not something that, to be realistic, not everything can be actually fully automated or controlled by AI. Certain things still need a very physical kind of involvement or manual involvement, but we are trying to move there as much as possible and as much as the resources allow, in terms of our internal resources and also equipment in the market and people who are able, to implement this. Because actually, Industry 4.0, you need a lot of people with knowledge, engineers of knowledge, to know how to put in the sensors, to figure things out and to make things automated. Yeah, so as that progresses, I'm sure we will also move along in that line together.
Thanks a lot, Cesar. I need to add on here. I think what brought up by Cesar is 100% correct, right? As in there's a scope for us to actually capitalize the Industry 4.0. And there's also a fair concern that the student asks, right? What does it mean, right? That means that I'm going to be jobless. So to me, that is too far-fetched, right? The whole industry being run by the robot, maybe happen in the Hollywood movie, right? But in the short term, right, 10, 15 years down the road, to me, it's actually, when Cesar said we need to have a system, right, to capture the data and then to analyze the data, to automate the system. Tell me, who is going to design that system? Only engineer. And in the plant, there's 1,000 million data being generated every second. And you don't rely on the system to capture the data. You need an engineer to identify which data is important, right? Which data need to be filtered out. And then how to analyze the data. System itself will not know whether this data is okay or not okay. It requires engineer input to tell the system. And that's where I believe engineer still have a big scope for us in this era, IR 4.0. We need to input our technical know-how. We need to tell the system, research system, this system is needed. This data, no need, it's a noise. And in terms of this system, which one is the outlier, which one is the optimum data? We need to give all this input to the system and then let the system help us to run the automation. That is how I see things going forward, at least 10, 15 years down the road. I do not have a crystal ball. I can't predict 100 years, right? But at least 10, 15 years down the road, engineer, you are still very, very much needed. Don't worry, right? But again, like what Cesar said, you must have a critical thinking. That is the fundamental that you've been trained at university, right? You can't rely that, okay, I'm 4 flat, but so what, right? You can't memorize all the syllabus. You must have a critical thinking. Million of data, which data is important? How do you want to capitalize the data? And how do you want to make use of all this data? This is your job. Help us again. The industry is very much welcome you. Thanks.
Yeah, I completely agree with Hong on this. At the end of the day, the simple message is all these are calculators and technology. The brains still come from you, you know. So, you know, at the end of the day, we still need the engineers to make sense out of all of this. You know, it's very, very crucial. You know, just like when you guys do your process simulation as well. Okay, the first step of happiness is everything converges, everything looks nice, everyone happy. But the second important happiness is when everything makes sense, lah. Okay, so yeah, so that's the second part that we always have to look into. And just to add on from the previous question as well, the industry also is looking at different kinds of ways. Of course, I mentioned empty fruit branches and also palm fronds from the plantation as well. And pomme, which I mentioned earlier, as co-products. So this is what Michael from MPOC is also adding on as well. Thank you for that. So the tree trunks as well from the palm plantation as well can be used as furniture, all right? Can be used as furniture. So in the end, a lot of the products that we produce or the byproducts or the so-called waste from the value chain of palm oil, there's a lot of work into utilizing them for various downstream processes as well. All right, thank you.
All right, so another question, I believe that this is directed to POPSIC or in general. Why is there in the supermarket, there is cooking oil that is blended? What are the purposes of this blending and how to choose a good blended oil?
Hong, you want to take this?
It's a good question, actually. It's a good question, right? Now come back to actually it's a customer or consumer preference, right? That's why there is a lot of the blended cooking oil. But again, fundamental come back to the point here is the as compared to other vegetable oil, right? Not to say I'm advocate, right? But it's actually let the facts speak for itself, right? Palm actually contains a lot of nutrients, especially the vitamin E, right? That's why palm oil is actually rich in color. They're rich in the carotene and vitamin E. And this vitamin E is very useful, right? We all know that. But why? To the question, why is actually blend with the other material? Is actually consumer perception, right? Consumer perception. What does it mean? Is it a wrong or correct perception? Again, perception. There's no right or wrong, right? That's why we are here to actually give another side of the story. Besides the blend oil, I will also encourage you, right, to look at the pure oil or wheat palm oil that are available in the market. And always do yourself, right? You are a chemical engineer, right? Compare the ingredient, compare the nutrient. I believe you are able to compare these two things, right? So will not give you a straightforward answer, but will rather encourage you to do your own research, right? Why there's a blend oil? Why there's a wheat palm oil? What is the benefit of this wheat palm oil? Why is that carotene or vitamin is so important, right? So these are the things that I think it's a good platform for you to reaching again. What do you mean by reaching? Is actually whatsoever we perceive for the past 10, 15, 20 years, right? From our mothers, grandmothers, right? I wouldn't say it's a wrong, but maybe it's time for us to reaching again for tomorrow and reflect again. What is your needs? What is your thought about the perception that you've been told, you've been actually advised, right? So yeah, do your own research and then give yourself a chance to compare the wheat palm oil, maybe. In fact, for information, every day, right, I consume a teaspoon of wheat palm oil. Perhaps that's make me look very young. Of course, I'm very young, right? But that further added to the advantage. I do consume a chocolate trianol as well. And as sidetracked a bit, right, I like to talk about palm. Earlier, Cecil said that basically we shouldn't have any expectation from the fresh grade. After all, what you guys what do the industry expect, right? 3 or 4 months in the internship. I think that's also true, right? That's why during internship, attitude is very important, right? Must be humble. But that because of this 3 months internship in the palm plantation, right, in the palm oil mill, that's what made me today. Today, I'm still very active in the palm oil industry, and because of this 3 month internship in the palm oil mill. So give yourself a chance to explore it, right? It's good to do some research, and but eventually, again, you must have a critical thinking, right, to balance the viewpoint, and then to digest yourself which information is a misinformation is a false, which information is a correct one, right? Shouldn't allow the media to influence your decision. Again, you are an engineer, right? You are capable to do that. So make your own decision. Give yourself a chance. again, the industry needs you. Enough. Thank you so much.
May I add?
Oh, yeah.
Sorry.
Go ahead. Yes.
Hi, everyone. Regarding the question on blending, right? Just to add to what Hong was saying, basically, blending allows you to sort of like take the best attributes of the oils that you're trying to mix together with. So if let's say, for instance, palm oil is known to be very stable when it comes to frying. So, but if let's say in an application where you want to use soybean oil, then you will have to blend soybean with a little bit of palm oil in order to gain that oxidative stability that palm oil has. And also the other way around, because palm oil has a neutral taste, you can blend it with, say, soybean oil as well to gain that soybean flavor. So it's blending is all about just getting that right formula based on the qualities that you want at the end of the day for your end products. Yeah, so that's pretty much it. Thank you.
Thanks, Harish. The thing is, I was going to be a bit more controversial. You eloquently put it. I was just going to say that the other oils need palm oil. That's why it's blended. So I was going to go more.
That's true.
Yeah, I was just going to go
they
more
need
upfront.
Palm oil. Otherwise, just to add a bit more, otherwise they will have to go through partial hydrogenation, which is really bad for health. Partial hydrogenation would produce trans fatty acids, which is controversial at the moment. And I think a lot of countries are also limiting the level of trans fatty acid allowed in their foods, imported foods especially. So yeah, that's they still need palm oil no matter what lah. Yeah, thank you.
All right. So for the next question, I think this is another open-ended question. But feel free for Mrs. Caesar or Mr. Chai to give your insight from the KEWPUMP perspective. How do the palm oil industry cope in the COVID-19 pandemic?
Okay, so I think I will take this first, and everyone else can complement in because I did a study on this actually. So, and I think Hong is also aware of this anyway. Yeah, so we did a separate study on this as well on how the economic disruption had an impact on the palm oil sector. And generally speaking, during the pandemic, the palm oil sector was one of the essential sectors that were operating. So because it's servicing a lot of very important other downstream sectors as well, especially the food industry as well. So in terms of operations, it was, I would say, not affected. But of course, due to the general worker shortage in the country, I think when the pandemic hit, I think a lot of sectors were also impacted. So I think in terms of labor shortage, I think it got intensified because of that issue. You see, so and because of the travel restrictions and all that, we notice that is a major issue. But in fact, in terms of operations wise, the palm oil industry was able to operate. So in that sense, when we studied the economic impact from that angle, they were completely okay in that sense. It's only about matter of productivity and operability because of labor shortage. Yeah, so that's where when we're talking about labor shortage, we're talking about, having people over from overseas coming in and stuff like that. The travel restrictions impacted that. Yeah, but open to everyone else also to chip in as well.
No harvesters.
Sorry?
Yeah, there were problem in the plantation because there were not enough harvesters. Yeah. That was the greatest impact.
Okay. How about
and for engineering point of view, the biggest challenge we face during the COVID-19 is most of our facilities, the computer power is all in the office. So due to we can't really go to the office, so that affects our progress of the works. So due to this COVID-19, we really need to seriously think about the cloud-based engineering software now. Yeah, this is the biggest impact that we're facing now actually. Because the engineering files normally is very big. It's very difficult to upload to like Google Drive or OneDrive and download it back to your home computer. And most of the staff home computer, they're just not sufficient of the computer power. So most of the jobs have to like delays. Yeah,
engineering point of view, that will be the biggest challenge that we face now.
Yeah, I think the COVID actually kind of like give a bit of a kickstart to the industry 4.0. So made kind of people suddenly thinking about, hey, cannot go office, how to work remotely, and how to monitor the plant remotely because you can have 50% capacity and things like that. So I think, yeah, if you look at the positive side of things, this is one of the benefits to the industry, I think, pushing us a little bit faster towards industry 4.0.
Yep. I mean, not to add on, but just to summarize, right? I saw a joke, which are the C, among 3C, right? Which are the C that actually trigger or speed up the transformation of company? A, is it a CEO? No. B, is it a CTO? No. So the answer is C, is a COVID-19 that actually speed up the transformation. I fully align. I mean, 1 year ago, who is talking about the virtual meeting, right? We are not talking about the virtual roadshow, but 1 year later today, just 1 year later, we are so expert on this virtual setting. So yeah, there's a way forward, fully aligned.
Mic drop moment.
All right, thank you so much. But due to time constraint, that is all for our first Q&A session. For the unanswered question, we'll post the answers on our social media later. Once again, a big thank you to our speakers, Dr. Vignesh, Engineer Hong, Mr. Caesar, and Mr. Chai. It was indeed a very informative and mind-stimulating session. Hopefully, when the pandemic recovers, we can physically visit the KEWPUMP factory or meet Dr. Vignesh and Engineer Hong in person in any future event soon. Up next, we will have a representative from Malaysian Palm Oil Council, MPOC, where you have probably seen her on screen just now. But before that, we will have a short intermission. So stay tuned. All right, guys, welcome back. I hope everyone is pumped for our next session with the Malaysian Palm Oil Council, commonly known as MPOC. Today, we are delighted to have our speaker, Ms. Arich Taufik, to deliver her talk on the Palm Oil Council. Ms. Arich Taufik is the current Senior Executive in the Science, Environment and Sustainability Division in the MPOC. She obtained her Bachelor of Science in Food Studies from University Putra Malaysia and further completed her postgraduate studies at the School of Food Science and Nutrition at University of Leeds, UK, where Ms. Arich has been awarded with Master of Science in Food Quality and Innovation. Once again, please welcome our speaker, Ms. Arich.
Hello, everyone. Thank you, Bashira, for the kind introduction. I think I'm going to share my screen now. Hold on, yeah. Oh, shall I share my screen now? Or okay. Right. Can everyone see?
Yes, Ms. Arich.
All right. Okay. Good morning, everybody. It's still morning. It's 11:40 a.m. My name is Arich Taufik, and I am currently serving the Malaysian Palm Oil Council. So it is an agency under the Ministry of Plantation Industries and Commodities. So today I'm going to take you guys through introduction on nutritional benefits of palm oil. Right, so let's look at palm oil in the global context. Just an intro. Global oils and fat supplies, based on recent stats, have shown that palm oil is currently at #1, surpassing soybean just a few years ago at 30%. So it accounts 30% of global supply of fats and oil. And despite the tremendous supply, right, you may find it shocking that it is the most productive vegetable oil in terms of yield per hectare. So it's like at 4 tons per hectare. And palm oil occupies 7% of the total global vegetable oilseed planted area. So there are at least, I think, 17 or 18 vegetable oils produced around the globe. And palm oil only occupies 7% of the total planted area of those of all the oil seeds altogether. So that's quite something to ponder on. And then out of all the total agricultural area in the whole world, palm oil only occupies 0.4%, which is less than 1%. So that's even more impressive. Okay, despite all the rumors, all the negative claims that you see on media in general. And then you may wonder, what can you do with this much oil, right? Evidently, I think all the other speakers have fantastically spoken about it. They are being used in food, oleochemicals, biofuels, and renewable energy. Yeah? So some facts to share with you guys. The Malaysian palm oil industry. Okay. So basically, the Malaysian palm oil started, the industry started about 100 years ago. And the oil palm tree is a perennial crop, yeah, where it starts yielding palm fruits for oil about 3 years after planting, and it has a continual productive lifespan of 25 to 30 years. Right, and the total planted area, based on recent stats, is 6.1 million hectares, and it only occupies 18% of total area in Malaysia. And despite all the negative claims from the media, our country has still managed to maintain more than 50% of forest cover. Right, a bit on the governance of the palm oil industry. The custodian of palm oil industry governance is the Ministry of Plantation Industries and Commodities itself, MPIC, my big boss. And the key agencies are MPOB, which is the research arm, and then you have us, MPOC, the marketing promotion arm, and then MPOCC, which is the certification council. Yeah. Right. So let's look at the oil palm fruit itself. I think someone mentioned fresh fruit bunch. Right? This is how the fruits look like on the oil palm tree. It comes in a bunch, pretty much like a whole banana bunch. So it's made of all these single oil palm fruits, okay? And if you dissect the fruit, you'll see that there's kernel, which is the seed, and mesocarp, which is the flesh. All right, so from the kernel, you get a whole list of oils, and from the mesocarp, you get a whole list of oils, okay? So you can get crude palm kernel oil and crude palm oil, and you can further refine these oils to get palm kernel oil, or PKO in short, and palm oil, or PO. And if you were to do fractionation, which is separation process, you can get palm kernel oil, palm kernel olein, as well as palm kernel stearin, and palm olein and palm stearin. So in general, if you were to look at the fatty acid composition, well, although they come from the same fruit, they have different fatty acid composition. Okay, so palm kernel oil is really high in saturated fatty acid. Okay, our major fatty acid is lauric acid at 49%. So the saturated fatty acid composition in overall is about 82%, while in palm oil, it's a bit more balanced. Okay, you have 50% saturated fatty acid, where majority of it is palmitic acid alone at 45%, and then you have mono unsaturated at I think about 45 or 40%, yeah, and the balance 10% is polyunsaturated fatty. So it's very balanced. You have combination of 50 unsaturated, and then the other 50 is saturated fatty acid. So just to give you guys like a better visual as to how it looks like, right? So basically, these are at the top here, these are refined, bleach, and deodorized RBD, palm oil, and palm kernel oil. So the crude ones look pretty much similar like this. You know, you can see that they are like solid sediments at the bottom, and the liquid fraction is on top. So when I said fractionation, you are going to just process this biophysical process, right? You separate them and you get the olein or liquid fraction, and then you get stearin or the solid fraction of the oil. So obviously they all function differently. They have different fatty acid composition, but it's not too massive like if you were to compare it palm olein with say olive oil or soybean oil. So obviously, if you look at the chart before, there are because of the difference in terms of chemical properties due to the different fatty acid composition, they serve different functions. Like I said earlier, they are applied in food, they're applied in renewable energy, as well as oleochemicals, etc., etc. And also, as I said before, palm oil has a balanced fatty acid content. So if you look at this chart right here, if you move towards the right side, the oils are less stable. You know, they have decreased stability. So oils like soybean oil, corn oil, and sunflower oil. So as someone asked just now during the Q&A, that is why blending occurs. You know, because they have decreased stability, they blend with oils that are more stable. So, and because palm oil is so widely available out there, and it's so stable and it's balanced and has a neutral taste. So manufacturers tend to blend these kind of oils with palm oil, because it doesn't, due to its neutral taste, it doesn't temper with the flavor that they want from, let's say, soybean, soybean flavors, so on and so forth. So if you look towards the left, there's increased stability. So palm kernel oil is way more stable than a typical palm oil or palm olein or palm stearin, right? And basically, polyunsaturated fatty acid, right, which is abundant in all these types of oils, which are, as I said, are not as stable. It's because POFA are easily oxidized, yeah, and so some, as I said before in Q&A, they are partially hydrogenated to make them stable. So if they were not to be blended with palm oil, they will go through partial hydrogenation, which I'll talk further in my slides later on. Right, so let's talk about the main thing here, nutritional benefits of palm oil. So before we go further into that, maybe we can just address, ask ourselves, is saturated fatty acid truly bad for health, right? It's been said all around that it has negative effect on coronary heart disease risk. However, recent studies have shown that there is no particular evidence that the reduction in saturated fatty acid consumption reduces cardiovascular disease risk, meaning that the less you consume SFA, saturated fat, the less susceptible you are to getting cardiovascular disease, right? There is no concrete evidence just yet, right? And palmolene showed similar effects on the level of total cholesterol and LDL cholesterol when compared with MAFA and PAFA-rich oils, such as olive oil. Okay, a study has shown that the effects that palmolene has on the level of total cholesterol and bad cholesterol, LDL, when compared to olive oil is rather similar. Okay, so if you were to just put a blanket on all sat fat and say it's bad because it would increase LDL, so on and so forth, it's not necessarily true, because at the end of the day, studies have shown that in fact the effects are quite similar to an oil which is rich in unsaturated fatty acids such as olive oil. Okay. And an increase in HDL cholesterol, which is the good cholesterol, was more apparent following the consumption of palm oil than the MAFA-rich oils. Okay, this has also been proven in recent studies. So apart from that, right, let's dive into the major phytonutrients, phyto meaning plants, nutrients in palm oil. So when you talk about palm oil, there are two main phytonutrients lah. Vitamin E and vitamin A. So vitamin E, refer to them as tocols, which are, slide am I on? All right, which are tocotrienols and tocopherols. So you can find them in palm oil. And then you can also find the precursor of vitamin A, which is carotenoids. Okay, so precursor meaning that when you consume it, it will be converted into retinol or vitamin A in our body. So according to Harvard, some of the sources of vitamin A include, it's a long list, but some of them are wheat germ oil, peanuts, peanut butter, avocado, palm oil, spinach, yeah. And so vitamin A is basically a fat-soluble vitamin, right? That's why you can find it in not just palm oil, in fact, in all these other things and also many other types of vegetable oils. But it comes in two major groups, okay? There's tocopherol and tocotrienol, okay? So the difference, as you can see, are these double bond groups, right? And in each of the group, you have 4 isomers, okay? So you have 4 isomers of tocopherol and you have 4 isomers of tocotrienols. And in fact, all 8 of these different forms have different, I mean, they all have varying antioxidant activities. Okay, some studies have shown that certain isomers have better antioxidant activity and ability compared to other isomers. Okay, right. So these are, in general, some of the potential health benefits of vitamin E. So if you were to consume tocopherols and tocotrienols, if you were to consume tocotrienol supplements, for example, these are basically just the general potential health benefits. But if you were to look at specifically, you may wonder which one would be better, yeah? So let's first look at this graph, yeah, where palm oil has one of the most tocotrienol in among vegetable oils. Rice bran has the most tocotrienol. However, it's really up to your preference as consumer. Rice bran is good as well because it's exceptionally high in tocotrienol, vitamin E tocotrienol. However, there are also other health implications like hypocalcemia, where it can suppress the level of calcium in your blood. But then again, yes, if you eat anything in moderation, it shouldn't be a problem. So if you eat palm oil in moderation, or anything in general, it shouldn't be a problem. Yeah, and so basically, according to a study, tocotrienols exhibit higher antioxidant ability than tocopherol. Okay, so basically, if your main concern is antioxidant ability of a particular nutrient, then you should go for tocotrienol rather than tocopherol lah. Okay, right. So if you were to dive into the exact benefits of palm vitamin E tocotrienols, there's a company called Excelvite. They focus a lot on tocotrienols from palm, and these are the 4 known benefits of palm vitamin E tocotrienols, based on in vitro animal studies Excelvite has done. So it's neuroprotective. It protects against toxic buildup in brain that may cause Alzheimer's and Parkinson's disease, right? It combats cancer, potential cancer cell growth, and proliferation of cancer cells, where it has inhibitory properties, like it can stop the proliferation of cancer cells. And for bone health as well, it's good. It protects against osteoporosis, okay, where it inhibits inflammation caused by oxidation. Yeah. And also for hair and skin, yeah, I myself have consumed vitamin E tocotrienol, and it does wonders to hair and skin. Yeah, I know the ladies out there be excited to hear this. It combats oxidative stress on the scalp and the skin as well. Right. Now, another thing, interesting thing that you should know, this is something that I've done. It's available on our website, so you can go to the link shown here. Palm vitamin E tocotrienols in frying is essentially effective in preventing lipid oxidation as compared to tocopherols. In this review, there's a comparison between soybean oil and palm oil in repeated frying. So based on this graph here, just to show you guys, after 5th frying session, right, the peroxide value, which is an indicator of deterioration in quality, the level of peroxide value in soybean oil surpasses the limit that the American Oil Chemist Society has stipulated in as maximum allowable value. Okay, so but palm oil evidently still less after 5th frying session. Okay, so which means that you can, to a certain extent, repeat the oil that you use at home, the palm oil that you use at home, frying up to 5 times. Okay, it's still safe for your consumption. Okay, right, and so generally, yeah, it's more stable for repeated frying and frying in general. Oops, sorry. Right, so apart from the 2 oils that I mentioned for, palm kernel and palm oil that we get from the seed and the mesocarp, okay, there's also Malaysian red palm oil, which also comes from the fruit, yeah. It undergoes, red palm oil undergoes a special refining method that retains its pro-vitamin A carotenoid contents that give this oil a brilliant red color. So as you can see, red palm oil usually, as the name says, it's red. It's brilliant red. Okay, and that's because it's rich in carotenoid, pro-vitamin A. Okay, so you can so if you were to just take the normal palm oil, there's still some traces, but not as potent as in red palm oil. Okay, that's why it goes through a specific patented technology. I think MPOB was the one who did it. So they were able to produce red palm oil where you can retain the provitamin A carotenoids, so the color remains red. So that's why it still has that flavor, okay, the distinct flavor. Whereas the typical frying oil that we use doesn't have that distinct flavor anymore because it has been refined, right? So this one, you don't use it for deep frying. Okay, you use it like how you use it an olive oil, okay, for salad dressing, stir frying can, even to a certain extent, you can bake with red palm oil as well. Okay, so, right, next. So basically, you'll be surprised to know that in comparison to other fruits and vegetables, red palm oil has higher retinol equivalents that are 50 times more than tomatoes, yeah, 44 times more than leafy vegetables, 15 times more than carrots, okay, etc., etc. So, contrary, I mean, you know, the media always says, you know, consume your carrots, but in fact, you should consume your red palm oil. Okay, it's the carotenoids is way more potent. Okay, it's at least 15 times more than in carrots. Right. Other than that, the red palm oil or RPO has been proven by so many studies that it's very beneficial for lactation. Okay, it decreases incidence of maternal anemia. Yeah? Increases alpha and beta carotene in breast milk and maternal and infant plasma, and increases retinol concentrations in lactating mother. So yeah, you would need for fetal development to some extent, you would need a good supply of vitamin A, but not too much. So you can always do your research when it comes to this. But if you need further reading, also it's available on our website, yeah, as shown here. And it's also a proven treatment for vitamin A deficiency. Okay, vitamin A deficiency in children causes visual impairment, blindness, risk of infection, and stunting. Okay, and there was a study where beta carotene fortified biscuit, where you introduce the red palm oil extract into a biscuit. Yeah? So you fortify the biscuit with beta carotene using RPO, where distributed in primary school in South Africa as a result, there's been an increase in blood retinol levels. And many other studies also conducted have shown to evaluate the impact of red palm oil supplementation on the blood cholesterol has shown positive impacts. Okay. Right, I think someone mentioned about pomade, right? Palm oil meaning effluent. So basically, it's a waste, right? It's a water waste, but it still has some nutrients. Okay, so the waste you can get, you go through solvent-free extraction purification. You can get bioproducts like polyphenols and flavonoids. All these oil palm phenolics, we call it. So these are water-soluble OPP, which are available in powder and liquid form. It's not really popular in the market yet. It's still quite new. They're still developing products. But it seems that because it's water-soluble, it can have various applications in food and beverage. So a lot of companies, I think, companies that are within our fraternity, MPOC's fraternity as well, they are developing products like drinks, ready, I think, as you can see in the photo here, juices and whatnot that are fortified with OPP. Okay, so you can also consume it as a nutritional supplement, as how you can consume vitamin E tocotrienol, but that one is in supplement form. That one is capsule form. This one can be liquid form lah. So the properties are, what are the properties? Okay, it acts as an antioxidant. Okay, where it helps in preventing and reducing the formation of free radicals. Free radicals, you know, it can cause all sort of bad things in your body. It can kickstart cancer, or God forbid. It also has anti-inflammatory property, yeah, where it reduces the buildup of fat or cholesterol in and on the walls of artery. And it's also cardioprotective, particularly in the regulation of inflammation, inhibition of platelet aggregation, vascular protection, so on and so forth. Okay. Right, so I did mention a little bit earlier about saturated fatty acid correlation with cardiovascular health. Yeah. So basically, more than 180 nutritional human studies evaluating palm oil conducted by the leading research institutions around the world have been done. And when palm oil is incorporated into the daily diet, where the total fats are consumed at WHO recommended levels, palm oil does not increase the total blood cholesterol or the bad cholesterol, LDL. Okay, and I mentioned before, it has similar effects on blood cholesterol profiles when compared to olive oil. Okay, so the blue one is palm oil, and the red one is olive oil. So these are two separate studies, and you can see they're pretty similar. Okay, so LDL is the bad cholesterol, and HDL is the good cholesterol. So it's quite similar, as you can see. Right, so just to touch a little bit on major food applications, yeah. Basically, these are the major ones lah. Cooking oil, which is the most major one. Dairy fat substitute, bakery fats, vanaspati, solid fry, medium, and even as confectionery fats. Okay, so palm oil is generally blended, yeah, as I mentioned, with other oils to make margarine, shortening, even vanaspati as well. They are blended. Okay, and as cocoa butter substitute, usually palm kernel oil is used as cocoa butter substitute because it has similar, as you remember the blue graph that I showed before, it has a similar fatty acid composition with coconut and shea butter. These two are usually used in confectionery fats. So palm kernel oil, due to the similarity with these two other fats, is commonly used as a substitute in the confectionery fats. Okay. And also in dietary fat substitute, right? Sometimes in ice cream formulation, they replace fat source from animal with palm. Okay. Other food uses of palm oil include special animal fat replacer. Again, just like the dairy fat substitute, it's pretty much well, not to say that in this particular application the animal fat is completely removed. No, like to a certain extent, certain percentage is removed perhaps and then replaced with palm oil, maybe to like stabilize, to improve the shelf life of the food. Yeah, same. And emulsifier and as emulsifier and stabilizer. Yeah. For instance, palm-based emulsifiers help to bind water and oil together to create emulsion. You can find this application in mayonnaise, okay, for example, and vinaigrette, homogenized milk, okay, and also as stabilizer, basically you can stabilize oil dispersions to impart smooth texture, okay, like in peanut butter. If you notice, peanut butter is always so creamy, always so smooth, kan? But try making it at home and you'll notice that without a stabilizer, the peanut solids would just remain at the bottom as sediments, while the oil would just go on top as one layer. So basically, a stabilizer would help to create like a homogeneous, nice smooth texture lah. Okay, so that is desirable when it comes to the industry, obviously. Okay, at home maybe it's okay for you to just have them separated like that, but obviously when you have it on shelf, it may not be a good quality lah. Okay, and even as cheese analog, okay, palm oil is used because it provides similar solid profile, solid fat profile as milk fat. Okay, so it has the texture and taste that's similar to dairy cheese. Okay, and also mind you, just to inform you guys, fat from the animal has cholesterol, but fat from palm oil does not have cholesterol, okay, because cholesterol can only come from animal sources, right? So that's why if you want to consume less cholesterol, then you go for something that has more palm oil, okay, that has been blended with palm oil, yeah. And also, it's also used in coffee creamers, infant formula. So in infant formula, it is used basically to match the fatty acid profile in human milk. In fact, even in normal milk, mammals, milk from mammals have palmitic acid, which, as I mentioned earlier on, it is the major fatty acid that you can find in palm oil, right? But it's also the major saturated fatty acid in human milk and animal milk. So that is why in some milks that you find out there, they can be to a certain extent addition of palmitic acid sourced from palm oil, because palm oil is so rich in palmitic acid. So you can use palmitic acid source from palm oil to maybe add on or blend with the existing milk, right? Or in terms of infant formula, to replace the absence of human milk so that you can create the same fatty acid profile as human milk. And then santan sawit, we did like a little video. You can find the video on YouTube, santan sawit, just Google it, santan sawit. The link is there. Basically, it's like, it functions like coconut milk, your typical santan kelapa. You can use it to make your cendol, your nasi lemak, everything. And in fact, it lasts longer than coconut milk. Okay, it lasts longer. It's more, it's less susceptible to deterioration lah. So you can keep it in the fridge for 2 to 3 weeks. Okay, in airtight container. Right. So let's talk about frying, the most famous application when it comes to palm oil. So what is frying basically? What it does, right? They immerse food in medium, like fat or oil, at a temperature of 150 degrees to 180 degrees. So the oil then becomes a heat transfer media between the food and the pan and the fire, okay, the source of heat. So, and what it does is actively removes water in the food, okay? And it's also a source of flavor and aroma. So if you fry with like certain type of oils that imparts flavor and aroma, then you get that flavor and aroma into the food that you're frying with, okay? And it also modifies food texture. Us Malaysians, we love fried stuff, right? Because of the texture, basically it's crispy. And it makes food obviously more palatable, like sedap. And it's a source of vitamins, fatty acids, and energy. And it provides lubricity between food and the fryer. Like if you don't have any lubrication, then it gets really dry. It may stick onto the pan or the frying pan, the baking pan, you know. So basically, during frying, there's deterioration of the oil. So during this, reactions such as hydrolysis, oxidation, polymerization, the 3 major deterioration processes, can cause the deterioration of the frying medium, i.e. the oil, i.e. palm oil. So basically, hydrolysis is when water from the food reacts with the oil, okay? And it enhances the breakdown of fatty acids, which occurs during the heating, throughout the heating process, yeah? So when this happens, you get free fatty acids as a result. And free fatty acids can do a lot of things. It can reduce smoke point. So when the smoke point is reduced, as the temperature goes up, the food will like burn a little bit, okay? And it also darkens and alters the flavor. And then oxidation is when, simply put, hot unsaturated oil reacts with oxygen. Okay, saturated doesn't quite experience this, but unsaturated will. So that is why, as I mentioned earlier, oils that are high in unsaturated fatty acids are much less stable when it comes to frying. That's why they are blended with palm oil, okay? Or they go through partial hydrogenation to make them more stable. Okay, and then this oxidation also initiates the other process, which is polymerization. So it creates, polymerization is when you can see viscous oil that is readily absorbed by foods that produces greasy products. So if you notice that sometimes when you fry, the food becomes a bit too greasy, that's because the food absorbs too much oil, and that's because the oil has pretty much deteriorated. Maybe too much frying already, so you need to stop reusing it, or maybe the oil is just bad in general, okay? It doesn't have enough antioxidants to combat polymerization process. So why at the end of the day do you fry with palm oil? Okay, why is it ideal for frying? Because number one is, mentioned many times before, it is stable at high cooking temperatures, okay? At 150 to 180 degrees, still steady, you can fry with it. It has high oxidative stability, resistance to oxidation, less oil absorption, so it's less susceptible to polymerization, so the food becomes less greasy, and it produces less volatile compounds, so you won't see as much, you know, residue sticking onto the wall as compared to frying with other type of oils. Okay. And you'll be surprised to know that you can use palm oil for baking as well. As shown before, you can use make margarines and what's that, the other thing, shortening with palm oil. So you can use it to create all sort of desserts, delicacies. Okay, so the role of fat in baking generally, again, as a heat transfer, but it also provides tenderness, improves overall texture, where, you know, the oil or the fat aids the formation of air pockets, let's say in a bread, for instance. So when air pockets are being formed, the oil sort of improves the texture, the structure of the air pockets, so the air retention is better. Okay, so you get like nice shape of bread. You know, when you look at loaf of bread, the bread will rise as you bake it. So that's due to a lot of factors. Yeah, it's due to the retention of air, it's due to the structure, due to oil, and the formation of the gas, the air, it's the gas itself, you know, from the interaction of yeast with sugar. So palm oil aids the whole process and improves the overall texture. So mouthfeel, right? Sometimes when you bite, let's say a bread roll, you can feel some kind of wetness in your mouth, right? It doesn't feel completely dry, and that's because of fat. Okay, it's either due to margarine or butter or anything, any kind of fats and oil. Okay, and it extends shelf life. So because it's abundant in antioxidants, specifically tocotrienols, so after you bake it, right, the shelf life of the product would be extended lah, due to the use of palm oil or its fractions. Yeah. So yeah, it provides lubrication and structural integrity lah. This one is pretty much related to the overall texture that I explained before. So basically, yeah, as I said, the good qualities of baking fat, you know, good aeration, retains gas bubble, and also semi-solid nature, right? In certain applications, when it comes to baking, when you want to, let's say, create a cookie dough, you would need a semi-solid kind of fat. So because palm oil is naturally semi-solid, so it makes it so much easier for, you know, those kind of applications where semi-solid quality is needed. Okay, because sometimes before you bake, there's a certain mixture that you need to create, right? So semi-solid nature is pretty much appreciated like those applications. And good plasticity, right? So good plasticity is the ability to be spread and shaped, right? So like in margarine, for instance, you would need good plasticity attribute in order for it to be spread perfectly. Okay, and so yes, as I mentioned, it's good for all these things, and it also provides creaming properties. Okay, where it sorry, hold on. Yeah, so for example, palm kernel oil is also a suitable raw material for making cakes. Yeah, where it imparts fat crystallization, fast crystallization, which provides great creaming properties. Okay, for your information, the fraction that is more commonly used for baking, for applications of baking, baked goods, it's usually palm kernel oil lah, and it's in its fractions, whether palm kernel, stearine or olein. It's usually palm kernel oil. It's more commonly used for those kind of applications. Okay. Right. So let's move on to this. Okay, as I mentioned before, partial hydrogenation and trans fat. Okay. So as I said earlier, trans fat is bad for health. Okay, there are two types of trans fat: natural ones, natural occurring ones, that can be sourced from animal fats. Yeah. animal products, they do have trans fat, which is natural and which is fine. The culprit, the villain is the industrially produced trans fats, or ITFA, okay, where it's not natural, right? So what happens actually, okay? Basically, hydrogenation is turning liquid oil into solid, right? From liquid, you turn it to solid. So there's level lah. If you go one level, it's not as solid, but if you go all the way, it will be very hard, maybe to the level of say shortening. Okay. So basically, this usually happens when certain applications require a bit of solidness. Okay, maybe like a semi-solid or a bit of solidity in the physical attribute of the oil in question. So usually it's oils that are not semi-solid in nature lah. That's why oil that is semi-solid in nature, like palm oil, where as I showed you, it has the solid fraction or liquid fraction. It does not need to go through hydrogenation process at all. Okay, you just need to separate the liquid fraction from the solid one in order to get two different fractions. Then you can apply and use them anyhow you want. But certain oils, that's not the case. So that's why they have to go through hydrogenation or partial hydrogenation, okay? Not all the way lah, hydrogenation, just partially. So you get partially hydrogenated vegetable oils. So in terms of manufacturing, it's good where the melting point would increase. So melting point will increase, meaning it becomes a bit more solid. So in terms of application, it's better, it's less susceptible to all sort of things lah. So in terms of industry, it's better for applications, processes, etc., etc. But it produces these dangerous trans fat, industrially produced trans fat. Okay, you can go and have further reading on our website. I did a bit of a review on this. So basically, it's better nowadays. A lot of countries are phasing out PHVOs from their market, but of course, there's still some out there. But and a lot of them nowadays, they are moving into blending those kind of oils that would require partial hydrogenation, blend them with palm oil, to increase melting point and for them to be more stable for all these type of processes. Okay, so basically, why are they not stable and why would they require this? It's because of linolenic acid. So linolenic acid is a polyunsaturated fatty acid, okay, and it's abundant in all this type of oils lah that would require partial hydrogenation. Okay, soybean, apa semua, they have high linolenic acid level. So this is not stable. It does not have. It makes these oils much more susceptible to oxidation. So they have less oxidative stability lah during frying. Right, so before I wrap up, just want to share with you guys our student ambassador program. I think I've shared this before with the PKUM, Persatuan Kejuruteraan UM, last 2 months, I think. We have an ambassador program where it's not an internship, but it's like you become a part of our fraternity lah. You become our ambassador. So you would, cultivate greater sense of pride for palm oil in our Malaysia youth, enable the youth to recognize and appreciate palm oil's vital role in our country. You sort of champion palm oil on behalf of not MPOC but the country, because this is our crop, kan? Our golden crop. It's for our economy and the livelihood of our people as well. So you'll be the voice lah. You'll be the central voice among the younger generation, among students. And the benefits of it, of course, you'll be exposed to Malaysian palm oil industry. Within our fraternity, we have, our network, we have like people from the industries. We're always in touch with IChemE, academia as well. So basically, you have like wider network lah when you join us, okay, and you have better career prospects, okay, because obviously when we have events, we'll tag you along, we'll invite you to come and you'll be able to meet potential bosses and do your pitch. And of course, to a certain extent, we would sometimes allow you to lead a program on your own, not on your own, but lead a program. So basically that would allow you to acquire some soft skills, build up confidence, effective communications, event management, okay? So yeah, that is all from me. I hope you guys join our ambassador program, and I look forward to more of this. Thank you so much.
All right, thank you, Ms. Arish, for the enlightening talk on palm oil. As the MPOC campaign hashtag goes, hashtag sawit anugerah Tuhan. Surely our palm oil industry has a big potential globally, especially with its function in blended oils and much more. Should you have more inquiries regarding MPOC, do visit their official website at mpoc.org.my or their social media page at MPOCHQ. Just to let all of you know, we will have a Kahoot challenge after this, but before we proceed, I would like to request everybody to switch on their camera for a photo shooting session along with our speakers today.
Hello everyone, I am the photographer for the photo shooting session. I would like to request everyone to switch on your camera to commemorate the session. Okay. 1, 2, 3. Okay. Another one. 1, 2, 3. Okay, last one. 1, 2, 3. Okay, thank you very much for your cooperation. Bashira, you may have the floor now.
All right, thank you, Farhan. And thank you everyone and to our wonderful speakers. A quick reminder to our speakers, kindly join the preparation room for a short debrief session. And as to our participants, I hope all of you are excited with the interesting prizes that await you for our Kahoot challenge. Thus, I shall now pass the floor to our next MC, Junhang. Thank you.
Okay, hello everyone. I'm Junhang, and I will be your host for this Kahoot session. Here's an important reminder. Please join the Kahoot challenge using your short name or initials together with your group number, or your entry won't be valid. For the exact format, please refer to the slide being shown right now. Okay, log on to Kahoot and we wait for some time for you all to join us. Okay, while everyone is joining, allow me to tell you guys about the prizes that we have for this session. The third and the fourth runner-up will be receiving prizes worth 25 ringgit each. The first runner-up will receive prizes worth 75 ringgit, while the second runner-up will be receiving prizes worth 50 ringgit. And finally, the champion for the Kahoot challenge will be receiving prizes worth 100 ringgit. All right, so do join. Extra. For those who are joining, please remember to rename yourself according to the format, right? Or else your participation won't be valid. Okay, it seems like the numbers is not moving, so we shall start now. Oh, 50% got it right. Okay, next question. Munir, you are the first one. TYH, first one. I think you all may answer it a bit faster, because the time is quite short. I saw some of you didn't manage to answer it. Only 30 something response. Yeah. Okay. Oh, this one you only know, only you joined last week. Huh? Oh, TYH got cut off. Oh, this one is very tricky. Type 1 between Munir and TYH. Last 3 questions. Last question. Come on. Munir, this is your last chance. Most accurate answer. Okay, let's see our winners. Third one is NAMZ. Second one is Munir, and the first one is TYH. Congratulations to 3 of you. And also we have our runner-up. Okay. You all remember to screenshot your details, yeah. If for the prize collection later. All right. So, okay. That ends our Kahoot session, and thank you everyone for your participation, and congratulations once again to all the winners. Let's give our winners a round of virtual applause, right? Okay, now we have come to our closing ceremony of IChemE Student Chapters Festival 2021, and it is the moment everyone has been waiting for. I will now be announcing the winners for the game session and the case study presentation we had last week. Okay. For the presentation of case study in the oil and natural gas session, the winning group is from Song, room 3, and we have Ng Zhenbing from group 5, Tiu Shitek from group 6, and Muhammad Aizat Imran bin Ashran from group 6. Congratulations to each of you for winning a Grab gift card worth 10 ringgit. Next up, for the presentation on safety and loss prevention, we have our winning team from group 6. Congratulations to Mah Brian, Hasna binti Tola from group 11, Alicia Chin Yingjie from group 12, and Lee Jun Hong from group 12. Each of you will be receiving a Grab gift card worth 10 ringgit. Moving on, we have winners for our game sessions from room 2. We have Oh Yan Yo from group 3, No Ashrin binti Sayuti from group 3, Wellington Candy Awis from group 4, and Shazia Ali from group 4. Congratulations to all of you on winning a Grab gift card worth 10 ringgit. And finally, we have a prize for the most participation, for the university with the most participation. This time around, we are joined by participants from 11 universities. And among all the universities, the university with the most participants is University of Nottingham. Congratulations to our friends from IChemE Student Chapter Nottingham on winning a cash prize worth 250 ringgit. For all the winners, we will approach you via WhatsApp or email after the event for the prizes. Please inform us if you didn't receive any message from us after a week. For all the participants, please do not leave the WhatsApp group yet for further info dissemination after the event. We have now come to the end of the event. Thank you very much for your participation. We hope that all of you enjoy yourselves throughout the event, and see you again at our next festival. Stay safe and goodbye.